Okay, in this video we're going to be having a look through some common paper 2 topics, and as you can see on the screen we have some updated checklists on the website that you can download showing you the topics that have appeared on paper 1. Now this will depend on your exam board, but if you head to the website you can download the one that's specific to you. But in this video we're going to be going through a load of common paper 2 topics, and you're going to be able to spend the last day of revision revising with me, going through loads of topics and hopefully making sure that you're nice and secure when you go into that paper 2 exam. Now we've got a lot to get through, so without further ado, let's get started. Okay, so in this question it says James buys 30 pencils, 30 pens, 30 rulers and 30 pencil cases, and then it gives us the price for different amounts. So we can get 6 pens for 82p. So if we start with that one, we're going to buy 30 of those. So if 6 are going to cost us 82p, we would want to multiply that by 5, and that would give us 30 pens. For the pencils, 15 are going to cost 45p, we want 30, so we'll times that by 2, that will give us 30. The rulers, we've got a price for 10, so we'll times that by 3. And the pencil cases, we've got the cost per pencil case, so we're going to need to multiply that by 30. It says what is the total amount that James is going to spend. So if we work these out, if we times 82 pence times 5, and on my calculator I'm going to type that in as 0.82, and multiply that by 5, so I get my cost in pounds. So 0.82 times 5 comes out as £4.10. Don't forget on your calculator that will come out as 4.1, but we want to write that in terms of money, so £4.10. For the next one, we have 45p times 2. I'm going to do the same thing. I'm going to write that as 0.45, multiply that by 2, and it gives us 0.9, which is obviously 90 pence, or 0.90. For the next one, we've got £1.25. We're going to times that by 3. So again, 1.25 multiplied by 3, and that comes out as £3.75 or 3.75 on the calculator. And then for the last one, 0.37, times that by 30, and we get our final bit of working out there, 0.37 times 30, and that comes out as £11.10 or 11.1 on the calculator. So we need to add all of those together. That's going to give us our total cost. Again, we're doing this on the calculator, so add £3.75, add 0.9, add 4.1, and that gives us a total cost there of £19.85. And there we go, there's our first question. Okay, so writing these temperatures in order of size. Now we've got negative numbers involved in here as well, so we're looking at kind of ordering integers, and we're looking at negative numbers. So we're going to start with the biggest negative, and that is the -5. So we'd write the -5 first, then we're going to look for the next biggest negative, which is -2, and that's the last of our negative numbers. So we're going to find our smallest positive number, which is 3 degrees. Then we're going to find our next smallest, which is the 7, and finish off with our 10. So don't forget, when you are ordering numbers and you have negatives involved, you're just going to look for that biggest negative to start with, which in this case was -5. And there we go, that's ordering some negative numbers. Okay, moving on to fractions, multiplying and dividing fractions. Multiplying fractions is the easiest one, isn't it? So we can times the top numbers, 3 times 2 is 6, and times the bottom numbers, 4 times 3 is 12. And we always want to simplify our answer, and a question will normally ask us to write it in its simplest form. So here we can divide the top and bottom by 6, and we get 1/2 as our final answer there. So always looking to simplify. On to the next one. We keep the first fraction the same, we flip the second one over, and we multiply them together. So times in the top numbers just like before, 2 times 5 is 10, 1 times 9 is 9, and again we'd normally be asked to write our answer in its simplest form or as a mixed number, and here it is an improper fraction. 9 fits into 10 once, with a remainder of 1/9 left over, so 1 1/9 would be my final answer there, and that's dividing fractions. When it comes to adding and subtracting, the process is the same. I'm just going to go for this one addition. So when we're doing this, we need to obviously look at the fact that there is a mixed number here, and we're going to make that into an improper fraction first, and the same goes for multiplying and dividing. So we're going to do 1 times the 4, the big number times the bottom, and then add the top. So 1 times 4, add the 3 is 7 quarters, and we're going to add to that this 2/3, and again, if that was a mixed number, we'd also convert that into an improper fraction. Now we need a common denominator when we're adding and subtracting, so that's going to be 12 on the bottom, so we can times this left fraction, top and bottom, by 3, and we can times this right fraction on the top and bottom by 4, and that's going to give us 2 fractions out of 12, so 7 on the left times 3 is 21 over 12, and on the right, 2 times 4 is 8 over 12. And now we can add these together, and again, if we were subtracting them, we'd just subtract those numerators now, but we'll add them together, and we get 29 over 12. And again, it says to give your answer as a mixed number, so we are going to convert this now into a mixed number. 12 fits into 29 twice, up to 24, and there'll be a remainder of 5/12. And again, there's my final answer. Just be very, very careful at this point, just to have a look. Does this fraction simplify here, the little one? It doesn't, but let's imagine it was 4/12 there instead of 5/12. That would actually simplify, wouldn't it? Because if it was 4/12, we could divide the top and bottom by 4, and that would end up being 1/3. So just have a look in that situation. Does it simplify? This one obviously doesn't. It's 2 5/12. Let's have a look at another one. So when we are putting fractions in order of size, if it was a non-calculator question, we'd be looking to make a common denominator. Now, if you look at these fractions, we've got 4, 7, 25 and 15. Now, there's no obvious number that stands out there as a common denominator that we could use. So as we're using a calculator method here, the easiest thing would be to turn these fractions into decimals just by typing them into your calculator. So if you type in 3 divided by 4 on the calculator and convert that into a decimal, so if you're using a Casio calculator, you can press that S to D button. If not, hopefully you can just get it straight into a decimal using another method, but that comes out as 0.75. 5 divided by 7 as a decimal comes out as 0.714, and a few more decimals after that. We'll come back to it if we need to. For the next one, 9 divided by 25, that comes out as 0.36. And for the last one here, 11 divided by 15, that comes out as 0.73, and there's a recurring above the 3. So in regards to that second fraction that we converted, we're not going to have to go beyond the 3rd decimal place there, as we can make a comparison just by looking at them as they are at the moment. So the smallest one is clearly the 0.36. So that's going to mean the 9 over 25 is our smallest fraction. So we'd write that one first and make sure we write the original fraction and not the decimal that we've used to help us. So that one's done. The next smallest is the 0.7 with the 1 after it, so this one here, the 5/7. So we're just looking at that second decimal place at the moment. That's 5 over 7. The next one, this decimal at the end had a 3 in the second decimal place, so that would be 3rd. So that would be 11 over 15. And then our final one, which had a 5 in the second decimal place, would be our final one, or our largest fraction there, and that is 3 over 4. And that would be our final answer there, getting our fractions in order of size, starting with the smallest. Okay, so this question asks us to write down a multiple of 6 that's between 40 and 50. Now, if you don't know your 6 times table perfectly, you could probably jump up to a number that you do know. Now, 6 times 6 is 36. We could start at 36 and just kind of work up in terms of a sequence. So if we add 6 to that, that would become 42. Add 6 to that again would be 48. Add 6 again would give you 54. And obviously the only two that are going to be important to us would be 42 and 48, as they are between 40 and 50. But of course this question does say write down a multiple, so it doesn't want us to write down both of them, it just wants to write down one. So you could take your pick. I'm going to pick 42, so let's just say 42, and that is a multiple there that is between 40 and 50. And just being careful to read the question if it says write down a multiple, or if it says write down all the multiples. So there we go, that's how we would approach that question. Okay, so looking at some rounding, and we're going to look at rounding significant figures. Of course, you could be rounded to decimal placing or you could be rounding to decimal places as well, but we'll look at significant figures as they tend to be the ones that are not answered quite as well. So for this first one here, we've not got a decimal number involved, we've got 7,357. Now, if we're going to round that to 3 significant figures, we just need to look at where the third significant figure actually is. So the 7 is the first, then the 3, and then the 5. And that 5 is in the tens position. So in the case of this question here, we're going to actually round this to the nearest 10. So looking at the number after that is a 7. So if you do your little rounding line after the 5, and that 7 is obviously 5 or above, which means it's going to round the 5 up to a 6. So that's going to become 7,360, rounding it to the nearest 10. Obviously there was two options there. It was going to go to 7,350 or 7,360. And because of that 7, we're going to round it up, and there is our final answer. Now the next one here does have a decimal in there, but we treat it in the same way. So we've got 2.456, and we're going to round that to two significant figures this time, and the second significant figure is the 4. Now that is in the first decimal place, so again if we translate that, it just means round it to one decimal place. So that's going to be 2 point, and it's either going to be 4 or 5. So again, looking after the line, that is a 5 after the line, so that means it's going to round up again. So our final answer would be 2.5, and that would be rounded to two significant figures, which also meant one decimal place in this particular question. Okay, so this question says Carla rounds a number x to one decimal place, and the result is 7.2. Write down the error interval. So when we're writing the error interval, we're going to put that letter that's given to us in the middle, so we'll put x in the middle, and on either side of it we're going to have an inequality symbol pointing to the left. Now on the left we're going to write down our lower bound, and on the right we're going to write down our upper bound, and we're going to think about these symbols a little bit more once we've written them down. So in order to go for 7.2, we're going to think, okay, well what's the number above that, and what's the number below that, and they're called the lower and upper bound in case of its rounding. So 7.2 is in the middle of 7.3 and 7.1. Now in the middle of those numbers, in terms of the rounding, we look at the 5s, but after that number. So this would be 7.15, and this would be 7.25. And they're the bounds that would allow us to round to 7.2. So 7.15 is the smallest that the number could have been, and 7.25 is the largest the number could have been. Now we've got to think about this a little bit carefully, because 7.15 would in fact round to 7.2. So on the inequality symbol we can put a little equal to symbol as well, because it can actually be equal to 7.15. Well, that's not the case for 7.25, because 7.25 to one decimal place would actually round to 7.3. So we don't put an equal to symbol with that inequality, so we're going to leave it how it is, and that just means it's got to be less than 7.25. So there we go, that's looking at error intervals. Okay, so this question says for each statement below, put the correct symbol from the following. So we have less than, greater than, or equal to. So for the first one, 3.4 is less than 3.6. So we put the less than symbol there. For the next one, -2 is actually greater than -3. So we put that -2 is greater than -3. And for the next one here, we've got to be a little bit careful. It says 25, and here we have -5 squared. Now when you square a negative number, you should actually put it in brackets, particularly if you are using a calculator. So if we do -5 squared, that actually comes out as 25. And we should know that already, because a negative and a negative multiplied together make a positive number. So they're actually equal to one another. So there we go, that's what we would do if we were putting some mathematical symbols into some statements like on this question. And again, just a little reminder there on being careful when you are squaring a negative number. Okay, so moving on to algebra, and we're looking at index laws to start with. So we know with index laws, we've looked at this when we have powers that are getting multiplied together when they have the same base number. These powers can be added together, so 2 and 3 would make 5. We also had the process when they're being divided. So x to the power of 7 divided by x squared, we take away the powers and we get x to the power of 5. And we also have powers in brackets, so if we have x squared to the power of 5, we multiply the powers, so we get x to the power of 10 in that particular example. Now having a look at this one, we've got 30x squared y to the power of 3 on the top and 6xy squared on the bottom. So we're doing a divide. Now we've got these numbers on the top and the bottom, 30 on the top, 6 on the bottom. So numbers always just divide numbers, so 30 divided by 6 gives us 5. Now individually looking at the letters, we've got an x squared, and on the bottom we've got an x. Now it's not written in there, but that is a little power of 1 there that's not written. So if we subtract the powers, 2 take away 1 gives us x to the power of 1. I'm not going to write that in, I'm just going to leave it as x because that means x to the power of 1. Moving on to the y's, we have y to the power of 3, y squared on the bottom, and 3 take away 2 gives us just y on the bottom there. So our final answer would be 5xy. Okay. Looking at this one then, we've got powers in brackets, so we're going to be multiplying powers here. But we've got this number 2 in the start as well, so numbers always get treated like numbers, and that whole thing is being cubed. So we need to work out what 2 cubed is. 2 cubed is 2 times 2 times 2, which is 8. So we're going to have 8 at the start of this one. Multiplying the powers for the x then, x to the power of 2, that's going to get times by 3, so that's going to become x to the power of 6. And y there is a power of 1 which is not written, so 1 times 3 gives us y to the power of 3. And there's our final answer there. On to expanding brackets. This first bracket we are multiplying everything inside the bracket by b. So b times 3b, well, not forgetting there's a 1 in front of that. 1 times 3 is 3, and b times b is b squared. On to the next one, 1b times 7. Well, 1 times 7 is 7, and there's just that 1b that we're going to leave in there, and we're just going to copy that symbol, which is a plus, so keeping that as a plus. On to expanding below. We have 3y times 5. 3 times 5 is 15, and we've got the 1y there, so we'll leave that as a y. And then 3y times the 4y, well, 3 times 4 is 12. Y times y is y squared. And then again, copying that symbol as a negative. Expanding and simplifying two brackets. So we'll expand these separately. So let's have a look at the first one. So 3 times 5 is 15, and 3 times 4 is 12. So we have 15x plus 12. On to the next one. Got to be careful with this one because it's saying take away, which means this is a negative 2 at the start of the bracket. So we're going to times both these pieces by negative 2. So negative 2 times 3x is negative 6x. And negative 2 times negative 2 gives us positive or plus 4. Now we just need to tidy all this up. So we have a 15x take away a 6x, and that gives us 9x's in total. And we have a 12 add a 4, and 12 add 4 is 16, that's positive 16, so we get 9x plus 16. Okay, so factorising, we're going to take out a factor and put this into brackets. So we have a look at both these pieces, 3x and 15. We just think what number goes into both of those. They both divide by 3, so we're going to divide this by 3. So 3 on the outside of the bracket, that's the factor we're taking out. 3x divided by 3 is just x, copy the symbol with a plus, and 15 divided by 3 is 5. And you can check your answer there. You can expand that back out just to check that you do get 3x plus 15. Now this next one says factorise fully, and that's because there's more than just one thing that comes out of the bracket in this one. So in that one above there was just a 3 that came out. So here we're going to have 2 things. And let's have a look at both these pieces. We've got 35x and 21x squared. So they both have an x in, so there's definitely going to be an x coming out. Just need to think with 35 and 21, what's the biggest number that goes into both of those? That is 7. So the highest common factor of those two numbers is 7. They also both have an x in, so we can take x out as well and then follow the same process. So 35x divided by 7x, or what do we times 7x by to get 35x? We'll have to times 7x by 5, but we don't want to put an x in there because we don't want to make that go up to an x squared. Copy the symbol. We times 7 by 3 to get 21, but we want that to be an x squared, so I'm going to stick another x in there with it. That would enable us to get an x squared when we expand that, and there's our final answer, factorised fully. Just a note, if you didn't take the 7x out and you just took a 7 out, for example, and this wouldn't be factorised fully, you'd have got 7 brackets 5x minus 3x squared. And you can see in that bracket there, there's still an x in both these pieces. There's a little hint there that you didn't fully factorise it. Okay, so on to solving simultaneous equations. Now we've got 2 equations here. I'm going to call this one 1 and this one equation 2, just so that I can talk about them. So when we're solving simultaneous equations, we want to make the coefficient, the number in front of one of the letters, the same. Now I always focus on this second one here, which in this case is the y. So on the top one we have 1y, and on the bottom one we have 3y. I know one of them is negative, but we'll deal with that later. I'm just purely looking at the number in front of it. So we have a 1y and we have a 3y. Now in order to make those numbers the same, I'm going to have to times the top one by 3, and that would make it a 3y. I don't have to times the bottom one by anything, but I might have to change them both in some of these questions. So let's have a look. If we multiply this top equation by 3, what does it become? So 4x would become 12x, the 1y becomes the 3y, and the number at the end will become 75. And that's my top equation. I'm going to rewrite the other one below it, which was 1x minus 3y equals 16. Now at this point I have the option, I can either add these two together or I can subtract them away from each other, but I want this 3y in the middle to get eliminated. Now if we think about the logics here, if I was to do 3y take away negative 3y. That would become a plus, and I'd end up with 6y. So taking them away is not going to work. I'm going to have to add them together. 3y add negative 3y becomes 0. So if we add these two equations together, we get 13x equals 91. Okay, so there is a little way of remembering those. If those symbols there are different, you add them together, and if the signs are the same, you're going to subtract them. Okay, but here we are, we have 13x equals 91. If we divide both sides by 13, we get x equals 7. Now when it comes to simultaneous equations, we have to not just find the value of x, but we also have to find the value of y. So what I'm going to do is I'm going to sub x equals 7 into any of these equations that we've got written down. I'm just going to have a look at the start. I think this one's going to be the easier one for me, just because it's got a plus symbol. So if I sub x equals 7 into equation 1, I won't have that x there anymore, and we can start to work out what it is. So again, using brackets, I'm going to do 4 lots of 7, add that 1y, and that equals 25. Now 4 lots of 7 is 28, so we have 28 plus y equals 25. And again, we just need to now finish this off to solve it to find out what y is. Well, 28 add y is 25, it goes down, so it's got to be negative. And if we solve this like normal, taking away 28 from both sides, we get y equals negative 3. And there's our final answer, y equals negative 3. So x equals 7 and y equals negative 3. I could have subbed this x equals 7 into any of the equations. I could have subbed it into equation 2. I could have even subbed it into this equation that we made up here. If I wanted, but I think I just went for the easiest one there. So let's have a think. If I did sub it into equation 2, we'd have had 7 take away 3y equals 16. Doesn't quite seem as nice here, because now when we take away 7, we have negative 3y equals 9 when you take away 7. And then when you divide by negative 3, 9 divided by negative 3 is negative 3. So we could have solved it in that equation as well, but I've opted to go for the easier one there. Okay, so we've got some worded equations here. 3 calculators and 4 books cost £23, and 2 calculators and 3 books cost £16. Work out the price of a single calculator and a single book. So we have to create the equations ourselves here. So let's have a look. We've got 3 calculators and 4 books cost £23. Well, let's just call the calculator C, so 3C, and, so plus 4 books, let's call that B, equals 23, and we've got an equation there that looks similar to the last question. The next statement, we've got 2 calculators, so 2C, add 3 books, so 3B, equals 16. There we go, so we've got again an equation 1 and an equation 2. Now we've got to follow that same process as before. I'm going to make these numbers, these coefficients of B the same, but this time I'm going to have to change them both, because one's a 4, one's a 3. So let's think, we could make those into 12, so I could times the top one by 3, and I could times the bottom one by 4, and that would give me a 12 in the middle. So if we actually work that out, let's have a look, what do we get? Timesing the top one by 3, and let's move this around. Okay, so timesing the top one by 3, we get 9C plus 12B, and 23 times 3 is 69. Onto the one below, timesing them by 4, we have 8C plus 12B, and 16 times 4 is 64. Okay, so looking at these symbols, the signs are the same, they're both a plus, so the way to eliminate this 12b is to subtract these away from each other. So I'm going to do the bigger one on top, take away the smaller one on the bottom. So 9c, take away 8c, leaves us as 1c. And 69 take away 64 is 5. So straight away we get our answer there, c equals 5. So there's our first answer, c equals 5. And then we just need to sub that back into one of these equations. Again, I'm going to pick equation 1, I think. Let's have a look. We could do either one here, but I'm going to pick equation 1. So if c is 5, we have 3 lots of c, or 3 lots of 5. Add 4b, and that equals 23. There we go. Now 3 lots of 5 is 15, so we're going to have to take away 15 from both sides. And we get 4b equals 23, take away 15 is 8. And then dividing that by 4, we get b equals 2. There you go, 8 divided by 4, b equals 2. So our final answer there, we got c equals 5 and b equals 2. Obviously thinking about the context here, that was a calculator is £5 and a book is £2. Okay, so draw the graph of y equals 2x minus 1 between the values of x equals minus 2 and x equals 3. Now, there's two ways of doing this. Again, we could make a nice little table, and we've got x values and we've got y values. Remembering this equation just means to find the y coordinate, you do 2 times the x coordinate or double the x coordinate and take away 1. Now it says between minus 2 and 3. So if I'm going to do a little table, I'd do minus 2, minus 1, 0, 1, 2, and 3. And all I've got to do is double them and take away 1 as the equation says. So if I start at the end with this positive number, double that is 6, take away 1 is 5, double 2 is 4, take away 1 is 3, double 1 is 2, take away 1 is 1. Now you might start to see there's a bit of a pattern here. Look, 5, 3, 1, those are all going down in 2s. So I can just follow the pattern here. 1 take away 2 is minus 1, and take away 2 again is minus 3, take away 2 again is minus 5. And we've got our coordinates here. Just looking at this one, that coordinate is minus 2, minus 5 as a coordinate. And all we've got to do is plot these and join them up with a ruler. So that's one way that we can do it. And I'm going to just draw that in to start with. So minus 2, minus 5's here, minus 1, minus 3, 0, minus 1, and the next few go there. And then nice and neatly with a ruler and a pencil, joining that up with a straight line. Absolutely not like I've just done there, which is absolutely terrible, but as best as you can with a straight line and a ruler. Okay, so that's one way that you can do it with a little table. You can actually do a little trick with this one, which is quite nice if you know what these pieces in there mean. So the 2 in front of the x, let's draw this over here, y equals 2x minus 1. The 2 there represents the gradient, and the minus 1 there represents the y-intercept. Okay, where it crosses the y-axis. So let's have a look there. It does cross through minus 1, so we could have put that point on straight away because we know it goes through minus 1, and then we could have had a look at the gradient, and that gradient of 2 just means for every 1 across, let's think from that point, so 1 across, it goes 2 up, and it goes 2 up. So you could do a little staircase here. You could just go again, 1 across, 2 up, 1 across, 2 up, to keep finding those coordinate points, and then tracing it backwards, so 2 down, 1 left, 2 down, 1 left, and you can draw this little staircase in. That's another way of doing it as well. Okay, so back to a straight line graph. Find the equation of this line and give it in the form y equals mx plus c. So I'm going to use that little trick process that I saw before. We're going to have a look for 2 coordinates here. I've got 1 coordinate there and another coordinate here. Now if we go across 1 on the x-axis, being careful of the scale here, because although mine goes up in 1s, sometimes you might have 2 squares for every 1, so just be careful of that. Now it goes across 1, and then it goes up 2. So it goes across 1 and up 2. So every 1 across it goes 2 up. So the gradient, the value of m, is 2. All we've got to find is that value of c, which as we've already said is the y-intercept, and it crosses the y-axis down here at negative 3. So c is going to be negative 3. So I just need to put those all together. We have y equals 2x take away 3. That's the equation of this line. We can do that nice and quickly like that. It goes through negative 3 on the y-intercept, and there's a gradient of 2 which I've found between those 2 whole number coordinates there. Slightly different one here because it's sloping in the other direction, but the same type of question. I'm going to take the same approach, so I'm going to find the y-intercept to start with this time, so c equals 1, and then we just need to find the gradient. So let's pick 2 coordinates. We've got 1 here and 1 here, and now this time for 1 across it goes 2 down. So 1 across it goes down 2. So my gradient this time is going down, and we'd say it's negative 2, so the gradient is negative 2. So y equals mx plus c, we have y equals negative 2x plus the positive 1 there for the y-intercept, and there's the equation of that line. Okay, so when looking at a number machine, we have an input and an output. So this number machine here, when you put the input in, you multiply by 3, subtract 4, and you get the output. So for part A on this question, it says find the output when the input is 5. So when we put 5 in, you multiply it by 3, and if I just write that here, and we get 15, and then we take away 4, and we get an output of 11. So for the first answer there, our answer would be 11. Now for part B, we're looking at it the other way. It says find the input when the output is 35. Now if the output was 35, the last thing that would have happened is we would have subtracted 4. So if instead of doing that we go backwards and we add 4, it must have been 39 before we subtracted 4. Now for the next step, we obviously, before that, multiplied by 3. So to reverse that, we would divide by 3. So if we divide 39 by 3, we get an input of 13. And again, you can check that going back through the number machine, because 13 times 3 would equal 39. Take away 4, that would give us 35. So our input must have been 13 for the output of 35. And there would be our two solutions there when looking at using a number machine. Okay, so there are lots of different conversions that we can look at, and there are lots of different versions of each of these conversions. So when we are looking at this, if we want to convert 3.45 kilograms into grams, we need to know that there are 1,000 grams in a kilogram. So if there are 1,000 grams in each kilogram, all we would do would be to multiply this by 1,000. And if we multiply that by 1,000, you can obviously type that in on your calculator, and it becomes 3,450, and that would then be in grams. If you are moving the other way, so let's say we were converting 3,450 grams into kilograms, we would simply divide by 1,000, and that would be one of the conversions when we are looking at mass. When we are looking at time, we have slightly different conversions, because in each hour, we are going to have to multiply by 60 to turn that into minutes. So if we have 2.5 hours, we just need to multiply that by 60. And of course, you can just type that in on your calculator as well, and that comes out as 150 minutes. So obviously, looking the other way as well, if you want to convert that amount of minutes back into hours, you can divide by 60, and that will give you the answer 2.5. Now, when it comes to area or volume conversions, these are a little bit more tricky. So when we are converting with areas, we need to think about the original unit conversion. So what I mean by that is to get from meters to centimeters, what do we actually do? Well, in that conversion, we do times by 100. Now, if it is meters squared to centimetre squared, instead of timesing by 100, we just times by 100 squared. And that would apply as well if it was a volume conversion, so we would times by 100 cubed instead. So for this one here, if we're converting 3.2 into centimetres squared, we just want to times that by 100 squared, and you can just type that in on your calculator, times 100 squared, and we get the answer 32,000. And that would be our conversion into centimetres squared. Now again, just like the previous ones, if we're doing that in reverse, so let's say we're turning centimetre squared into metre squared, instead of timesing by 100, to go backwards here, we would just divide by 100 squared. So you can obviously check that out. You can do 32,000 divided by 100 squared, and you'll see that you get 3.2. So knowing these conversions are quite important, and obviously knowing just to add the squared onto there if you are converting between areas can really help, obviously, particularly as you can just type this into your calculator. Okay, so when looking at scale drawings and scale models, we are given that the length of a car is 3.6 metres. It says Carl makes a scale model of the car and he uses a scale of 1 centimetre to 30 centimetres. And that could also be written as a ratio. It could be written as 1 to 30. Now it says here, work out the length of the scale model of the car and give your answer in centimetres. So to start with, we should notice that this is currently in metres. So as we've looked at with our unit conversions, we want to convert that into centimetres, and we can do that by multiplying by 100. So in terms of centimetres, that would equal 360 centimetres. Now it says in the conversion, or the scale here, that for every 30 centimetres, the model's only going to be 1 centimetres. Or the other way around, for every 1 centimetre on the model, the real car would be 30. So in order to do this, we're going to have to just simply divide by 30, and that's going to convert it down to our scale. So for 360 as the real length, we're going to divide it by 30, and that's going to give us our final answer, and that comes out as 12. So for our scale model of the car, the length of that is going to be 12 centimetres, and that would be our final answer. And again, that's just using it as a ratio, 1 to 30, or just in words there where it says that every 1 centimetre on the model will be 30 centimetres in real life. So there we go, that's how we look at scale drawings. Okay, on to writing some decimals as percentages. Now when we're writing decimals as percentages, any decimal can be converted into a percentage on the calculator by just multiplying by 100. So these are really nice and quick and easy to do on a calculator, because we can just do 0.7 times 100 and it gives us our answer, and it comes out as 70%. Now again, we can do that with this one below, 0.24. You can times that by 100 again, and it just straight away gives you your answer, and it comes out as 24%. So there we go, converting decimals into a percentage, nice and easy for us to do, and we can do that in any type of question. Whenever we get an answer as a decimal and we want to write it as a percentage, you just multiply by 100. Okay, so this one's a little trickier. It says James buys 6 kilograms of sweets for £10. He puts them into 250 gram bags and sells them all for 50p per bag. Work out James's percentage profit. Now for starters, we've got a little bit of converting units in here, hopefully nothing too horrible though. We've got 6 kilograms and we've got 250 grams. So we'd probably prefer to write this in grams. There are 1,000 grams in every kilo, so that would be 6,000 grams. So now we know how many grams he's bought. He's going to put them all into 250 gram bags, so we could work out how many bags he's actually going to have to sell. So if we divided that by 250, that would actually calculate for us how many bags he's actually got. Now there are 4 lots of 250 grams in every 1,000, and we have 6 of those thousands. So if we do 6 times 4, that gives us 24 bags. And again, you can take your time working that out, but every 4 250 grams is going to add up to 1,000, and we have 6,000, so 6 of those 4s is 24. So 24 bags of sweets, and he's going to sell them for 50p. So we've got to do the 24 bags, and we're going to multiply that by 50p. And again, you have to take your time here. Now I am going to do a little trick here, and that is because I know if I do 24 times a pound, that would be 24 pounds, and 50p is half of a pound. So instead of being 24 pounds, it's going to be half of that, which is going to be 12 pounds. So that's going to come out as 12 pounds. But again, you can obviously just do your working out to the side. You only actually have to do 24 times 50 using column multiplication. Again, we get 0 and 0, put our placeholder in. 5 times 4 is 20, 5 times 2 is 10, plus the 2 there is 12, and then add it all together and you get 12 or 1,200 pence, which comes out as 12 pounds. So don't worry about doing your working out to the side. In fact, I definitely encourage it here, but I just applied a little trick there, just to obviously put a little bit less writing on the screen for you. So £12 is what we're actually selling it for, and don't forget that we actually paid £10 for these sweets. So if we had £12 that we sold them for, £10 that we bought them for, that is going to be £2 in profit. So we've made £2 profit. There we go. So to work out our percentage profit then, this is quite a nice one because our profit was 2 out of our original, which is 10, and that is straight away going to be 20%. So there we go, that's 20%. And again, you could multiply the numerator and denominator there by 10, so it's 20 over 100. But ultimately we get our final answer, which is 20%. And again, you could take that original approach, and that is to work out 10% of 10. Obviously, and I keep doing this on every question for you. So 10% is 1. We want £2 profit, which is going to be double that. So 20% is £2, and there is your other method, which works every time for these as well. Okay, so this question says, Amy buys a new car for £18,000. Each year the car depreciates by 12%. How much will the car be worth at the end of 3 years? And obviously we could do this without a calculator, but we're going to have a look at doing some calculator methods here. So obviously the original value in terms of a percentage is 100%. Now if it loses 12%, so let's just say, okay, well we lose 12%, what percentage are we actually left with? And 100 take away 12 is 88%. Now there's actually something we can do here, because if it's going to be 88% of its value each year, there's something we can just times by straight away on the calculator, and it's the decimal version of 88%. And the decimal version of 88% is 0.88. And straight away, if we just times by 0.88, it will actually take away 12% for us. I can do that on the calculator, 18,000 times 0.88, and it gives me the answer 15,840. So that would actually just reduce it for me in the first year. And I could just do that 3 times. I could just times by 0.88 and keep on repeating that. Or I can actually do something to speed things up a little bit. And it's very similar to compound interest. And with compound interest, this is something that you add on to this multiplier here to get your 3 years. And it's a power of 3. So if I want to actually do this just 3 times very quickly on the calculator, I can do £18,000. And I can just times it by 0.88, and again I could do it 3 times, or just to speed things up a bit, you can just add a power of 3. Okay, and that will just be the same there. If it was 4 years, you'd put a power of 4, 5 years, you'd put a power of 5. Okay, and it'll just do it that many times for you. So if I type that straight into a calculator, 18,000 times 0.88 to the power of 3, and I get this answer here. I get £12,266.496. And obviously we are talking about money here, so we're going to have to round it to the nearest penny. So a final answer would be £12,266, and I'm just going to follow the normal rules of rounding, so I'll chop it off after the 9, and that rounds up to 50p there. So that 9 rounds up because of the 6, which rounds it up to 50p, so 0.50, and that'd be my final answer there. Again, just rounding to the nearest penny on any of these questions. Okay, so that's how you do it nice and easy on the calculator. Again, just thinking about the percentage, let's just pick a random one. If it depreciated by 23% each year, 100 take away 23 would leave us with 77%, and as a decimal, 77% is 0.77, so I'd times by 0.77. So just something to be thinking about there. Whatever the percentage it depreciates by, you can take that away from 100 and then convert it into your decimal that you're going to want to multiply by. So just a little bit of a quicker way that you can do this rather than having to do all those stages of each year. Okay, so when we are writing a ratio, it says here, write down the ratio of 450 grams to 15 grams. Give your answer in its simplest form. Now, of course, both of these are given to us in grams, so we can straight away write it as a ratio, but of course they might have been given in different units, and that would be fine for us to do as well. Like, for example, the 450 grams could have been written in kilograms, and we would have obviously had to convert it first, but as these are the same, we can straight away write that as a ratio. We would write it as 450 to 15. Now, of course, this one here says to give your answer in its simplest form. And if you are doing this on a calculator, it's really nice and easy. If you have the fraction button on your calculator, you can just write it as a fraction. You can write in, that's why I normally put the smaller number on the top, 15 over 450, and then actually simplify it for you. And if I type that in on my calculator right now, it simplifies it down to 1 over 30. Obviously, you're going to match these numbers up in the correct place. So the 15 became 1 and the 450 became 30. So our simplified ratio there would be 30 to 1. Obviously, if you don't spot that or you don't have that function available on your calculator, you just have to divide it down. And in this case, it was just dividing by 15, which you can just type into your calculator just to make sure that you fully simplify it. And there we go, that's our final answer. A nice little trick there to use your calculator to simplify a ratio if something like that comes up. It says here that 5 boxes of cereal have a total weight of 1,750 grams. It then says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490 grams. Work out the total weight of 3 boxes of cereal and 2 sachets of sugar. So this question's different because we have 2 different variables. We have the cereal and we have the sugar. So we need to figure out one of them first, and let's have a think about which one we can work out straight away. Because that first line just says about one of the variables, it just says 5 boxes of cereal have a total weight of 1,750. So we can work out one of the boxes by dividing that by 5. So let's just have a think. We've got 5 boxes is equal to 1,750. So our first step to get the weight of one box would be to divide that by 5. So we will divide it by 5 and we'll do our working out to the side. So 1,750 divided by 5, well, 5 goes into 17 3 times, remainder 2 goes into 25 5 times, and then 0 at the end. So the weight of one box is going to be 350. Of course, this is in grams. And the final part of the question, which we don't have to work out straight away, but it wants us to ultimately work out the weight of 3 boxes. So straight away we could multiply this by 3, and again you could work this out at the end once you've got the singular weight for both, but we may as well just straight away times that. So 3 boxes, and that is going to be 3 times 350. 2 times 350 is 700, add another 350 is 1050. Again, you could spend some time just adding 3 of them together using column addition or multiplying it by 3, but there we go, we have the weight for 3. So let's get rid of this working out and move on to our next piece of information. So the next part is obviously we have the sachets of sugar. So for this second line here, it says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490. Well, if we work out the weight of 4 boxes of cereal, as we know the weight of 1, then we could have a look at working out therefore what the weight of the 3 sachets of sugar are going to weigh. So if 1 box is equal to 350, 4 of those boxes is going to be 1,400 grams. And obviously it says in the question that the weight, including the 3 sachets of sugar, is 1,490 grams. So that is going to be adding another 90 grams. So those 3 sachets of sugar are equal to 90 grams. So we can write that down. So 3 sachets is equal to 90. Of course, we want to break that down and go back to 1 sachet. So we can divide that by 3. So if we divide that by 3, we're going to get that 1 sachet is equal to 30. There we go. And obviously the question here, and we'll swap colour again, wants us to work out the weight of 2 sachets of sugar. So we can straight away multiply that by 2. And if we multiply that by 2, we're going to get that 2 sachets is equal to 60. And that is the second part of our answer. Now, of course, this question here said work out the total weight of 3 boxes and 2 sachets. So we're going to want to finish this off by writing the total weight. And that is to take our 1,050 and our 60 and add them together. So for our final answer, we'd do 1,050 plus the 60, and that is equal to 1,110. And that is in grams, and that is our final answer. So quite a lot going on in that question. Obviously we had to work out the weight of one of the variables, then we used that to help us find the weight of the other one, and then once we'd found the weight of a singular amount for both, we were able to multiply them and work out the total weight for 3 of the boxes and 2 of the sachets. Okay, so this question says identical pairs of boots are sold in London, Geneva and in Paris, and the handbag costs €174 in Paris, £115 in London and 189 Swiss francs in Geneva. And it says the exchange rates are, and we've got £1 is €1.27 and 1 Swiss franc is 72 pence, or £0.72. In which city are they best value for money? Now obviously we're going to get them in the same exchange again, in the same currency, but this one here always tends to throw people because that is a bit of an odd exchange rate. That kind of exchange rate is the exchange rate we would be given if we were actually in Geneva and we were wanting to convert our money back into pounds. So it's not one that we see very often because normally it's always £1 to whatever the other currency is. So this is a little bit different, but again, all we're going to do is apply a bit of logic, and this is why I don't remember just times or divide for particular ways, because if we are given an exchange rate like this, we have to think logically about the size of our answer and which one logically is going to be bigger or smaller in terms of the number. So again, I'm going to take the same approach. I'm going to leave London as it is, as £115. I'm going to look at Paris and Geneva. So I'm going to start with Paris. Okay, so Paris, we need to convert the €174 into pounds. Now again, looking at the exchange rate, okay, so down here our exchange rate, the pound is now to €1.27, so the euro number is higher. So I need to divide by that exchange rate, so 1.27, in order to get it back to the smaller pounds number. I've got to be careful with the language that I use because obviously it's the same value, but in terms of the size of the number, it is smaller. So divide it by 1.27, and I get, and it's a nasty decimal, and don't be put off by that, I get 137 point, and then it's 007. So to the nearest penny, that would be 01. Okay, so it's a 7 after that in that third decimal position. So obviously that's now in pounds, so we've got 137.01. Now we can already see that that's not better off than buying it in London, so we can also almost forget about that one now. And now we're going to have a look at Geneva. There we go, so in Geneva, let's have a look. The cost at the moment is 189 Swiss francs. Okay, so 189. Now thinking about the logic of this exchange rate, you can see that for every 1 Swiss franc we get less than 1 pounds. So we know again that the answer in pounds is going to have to be smaller, but this time if I was to just divide, which obviously some people tend to remember it like this, you divide coming back home, you times when you're going away, but because this is the foreign exchange rate, if I was to divide by 0.72, which I'll do on my calculator now, 189 divided by 0.72, I get the answer £262.50, and that is a lot higher, okay? So when we've got the foreign exchange rate, we have to almost reverse the process and think logically, and actually it's just logically okay, well dividing didn't work, so we're just going to multiply by that exchange rate of 0.72, okay? And obviously that's what you'd do if you were actually in Geneva and you were obviously going off on holiday to London. You would multiply by the exchange rate, okay? So it's just giving us their exchange rate rather than our own. So 189 times 0.72, and that gives me an answer here of £136.08. There we go, so it's £136.08. There we go. So actually, as you can see, all of that working out, and actually it is just best value to just to buy these boots in London. Okay, so obviously these questions will normally say you must make sure you show all your working out, and there we go, that's all our working out there. So even though it's still in the London one, we're going to say it's best value in London. There you go. The boots are best value in London. There we are. Now obviously you could have taken a different approach here, you could have converted them all maybe into another currency. It wouldn't actually, I don't think we could have done with this one in particular because we don't have any exchange rate here between them, although we could have maybe converted the Paris amount into pounds and then into Swiss francs, and also converted the pounds into, we'd have had to do it in 3 steps rather than 2. So it was the most sensible idea in this question to convert them all back into pounds, but you could have actually gone about trying to convert them all into euros or into Swiss francs as well, but it just makes sense to always convert it back into our own currency, obviously. Just makes a little bit more sense when it's on the paper. So it says that A to B to C is a straight line. So that tells us that these two angles next to each other have to add up to 180. So that's something we might use at some point. But it says work out the size of angle, and it gives us something different here. It says angle BDC. So to find angle BDC, you go from point B to point D and then down to point C. And you can see that by drawing that, it has created this angle just here. So that is the angle BDC, and that is the one we're actually going to be looking for. So again, you can obviously trace your finger over the shape to find that at any point. So let's think about that. We've got a triangle on the right there, this one just here, which is a scalene triangle. There are no lines on that particular one. There is a line just here, obviously because this triangle on the left is an isosceles, but that line there doesn't necessarily relate to the triangle on the right. So the triangle on the right is a scalene triangle, all the angles will be different or could be different, and on the left here we've got an isosceles. So because we have that top angle in the isosceles, we can definitely work out these two base angles. Again, just finding the ones underneath those two little lines. So at the moment there's a top angle of 70, so if we do 180 take away 70, it's going to tell us what's left to be split between the two base angles, and that is adding up to 110. So if we divide that by 2, that will split it into our base angles, and 110 divided by 2 is 55 degrees. So both those base angles are 55. Now that's going to allow us to move into the other shape. As we mentioned at the start, these two angles just here are going to add up to 180. So to find this angle just next to the 55, we would do 180 and take away 55. And that gives us an angle of, and again you can do your working out for this, but that gives us an angle of 125 degrees. So this one here is 125. And now you can see we have enough information on this right hand triangle to find our missing angle, because we now have two of the other angles. So if we add those two together, we've got 125 and 29. And if we add them up, that adds up to 14, 5 and 1, so 154 degrees. And we want to take that away from 180. So to finish this off, our final bit of working out, we'll do 180, take away 154. And again, if you can do these mentally, that's absolutely fine. But we'll just do our written method for the purpose of this video. 10 take away 4 is 6, 7 take away 5 is 2, and 1 take away 1 is 0. So that final angle there is 26 degrees, and that is the final answer for our question, because there we have found angle BDC. Okay, so working out the size of angle X, again I've got 2 here, and we're looking at parallel lines. As you can see by these arrows here, these lines are parallel. So there are 3 rules that we're going to really look at when we're looking at parallel lines, as well as all our normal angle rules. We've got alternate angles, corresponding angles, and co-interior angles. So if we look at this one on the left here, 110, there's lots of angles we can find now. So all around this point here, we can find all of these angles. Vertically opposite the 110 is also 110, and then next to the 110 on the straight line there remembering angles in a straight line add up to 180, these would all be 70. There we go. So it's up to you really how you actually find this final one. I'm going to have a look at finding this Z shape here, which is an alternate angle, and alternate angles are equal. So this 70 here is the same as this 70 here. So x would equal 70 degrees in this one. And we'd normally be asked to give our reasons there. So my reason may have been angles on a straight line equal 180, and that's how I got the 70. And then I would have said alternate angles are equal, and that's really important the way you say that. So alternate angles are equal. Okay, there are also other ways that I could have done that. If I flick to another colour, we could have said, okay, well if this is 110, well then this here is also 110 because those angles are corresponding. And again, I'll try and draw this on a different colour, but they make this F shape, okay? So that 110 and that other 110 are corresponding angles. So we could have done it that way and then done angles on a straight line. Let's have a look at this other one. So 105 degrees down in the bottom here. So straight away, just above that, we can find that this angle's 75 because angles on a straight line equal 180. Now, if you have a look, we've got a triangle in this question. Now, there's these two symbols here, which tell us that this is an isosceles triangle, and base angles in an isosceles are equal, and it's underneath these two little, what I call little eyebrows. Okay, so underneath, this will also be 75 because base angles in an isosceles are equal. We can then find this missing angle here because angles in a triangle equal 180. So those two 75s equal 150. And if we take that away from 180, it leaves us with the other angle in that triangle being 30. There we go. And there's all the angles that we found just using basic angle facts. Now to get that angle x, there's a couple of ways we could do it. We could find this angle here and then do angles on a straight line. Or we could again identify that actually we've got one of these alternate angles going up, making this Z shape again. So that's an alternate angle with the 30. So that's 30 degrees as well. So for this one, we'd say x equals 30. And again, we'd probably give this same reason over here that alternate angles are equal. Unless, of course, we took a different approach, which we could have done. Again, lots of different ways that you can tackle these questions, but a few there that you need to make sure that you try and remember. So working out the size of the angle between this regular octagon and regular hexagon. So there's different ways that you can approach this, but we need to know what the angles inside a hexagon all add up to and what the angles inside an octagon add up to. There's different ways of doing this. You can do the 180 list rule, so you can keep adding 180, so 3 sides is 180, 4 sides is 360, 5 sides is 540, and you can keep doing it this way, or you can apply a bit of a formula. So I'm going to go for the formula, even though I've started writing this down, but that is an option there that you can use. So for 6 sides in a hexagon, we take away 2. So 6 take away 2, which is 4, and then 4 times 180 tells us the total amount of, oh, that should be a times sign. Let's change that. 4 times 180 gives us the total amount of angles in a hexagon, which is 720. So all the angles inside a hexagon equal 720, and there are 6 equal angles in there. So if we divide that by 6, 720 divided by 6 gives us 120 degrees. So all of these angles in the hexagon are 120. Obviously we're concerned about this little area here in this question because we're trying to find the angle between them, but we've got the angle in the hexagon, and that's really important. When you see these words regular hexagon and regular octagon, always just work out the interior angle and label it all over the diagram. So moving on to the octagon, same process, 8 sides, take away 2 is 6, and then times that by 180. There you go, and 6 times 180, which is okay if you have a calculator. If not, you just have to work that out, but 6 times 180 is 1080. And again, it's got 8 equal angles, so if we divide that by 8, 1080 divided it by 8 gives us 135 degrees. And again, we can just label that all over the diagram. So 135, 135, and lots of these, but I'm concerned again with this little area here. So angles around a point equal 360, and at the moment we've got 2 of these angles, kind of like a jigsaw. So if we add these 2 together, 120 plus 135, at the moment we've got 255 degrees, and we need it to add up to 360. So to finish that off, if we do 360 and take away that 255 that we've just worked out there, we get a missing angle of 105 degrees, and that's our final answer there, 105 degrees, which we could always label on the diagram as well, 105. And there we go. So whenever you see these questions where it says regular octagon, regular hexagon, okay, just spot these bits of language here, just work out their interior angles and label it all over the diagram. So when we're looking at circles, there's 2 formulas that we need to know. Circumference equals pi times diameter, and area equals pi r squared. Remember, the units for area have squared in, don't they? When we use centimetres, we have centimetre squared. So I always like to remember the little formula for area there is the pi r squared, the one with the squared in. So we're going to work out the area and the circumference of this circle. So to work out the area, we're going to do pi r squared if we start with that. So the area equals pi r squared. And we just need to know what the radius is. So over here, the diameter is 8. So we're going to first halve that for the radius. So I'll just write r equals 4. And we've just got to type that in. So pi times 4 squared. 4 squared is 16, so it'd be pi times 16. And you can just write that as 16 pi. So if it asks you to give your answer in terms of pi, you can just do that. But we want to type that into our calculator if not. So 16 times pi will give us a decimal, which is 50 point. I'm going to round this, but obviously only round it if it says to in the question. It'd be 50.27 if I round it centimetres squared, and that'd be an area there to 2 decimal places. Let's have a look at working out the circumference. So circumference up here is pi times diameter. Now we've been given the diameter is 8, so to get the circumference, we just do pi times 8, and we could just say 8 pi. So we could just say 8 pi, which just means pi times 8. But again, if it asks us to work it out, we're going to do pi times 8 on the calculator. So 8 pi, press equals, and we get, and if I round this to 1 decimal place this time, I get 25.1. And circumference is a distance, it's around the outside, so it's just centimetres, 25.1 centimetres. But again, rounding it to how the question asks, and remembering you can write it in terms of pi, like down here 16 pi, and up here 8 pi as well. Okay, so translating a shape by a vector. Now that top number in a vector means left and right, and the bottom number means up and down. Okay, thinking about positive numbers moving towards these positive numbers on the axes and negative numbers moving towards the negative numbers as well. So 4 moves it right towards the negative numbers by 4. So all I ever do is pick a point, you can pick any, and I move it right by 4. So 1, 2, 3, 4, it's going to end up there. The next thing I do is look at the other number, which is minus 2. Now negative 2 moves down towards the negative numbers. So 1, 2 down, and that means that new point is going to end up just there. So all I have to do is draw this triangle in exactly as it is from that top point. So it goes down 3 and across 2. And there we go, we can just draw it in like that. Not forgetting as well, you might actually be asked to describe a translation, in which case you'd say it just like it says above. You'd say translate the shape by a vector, and you'd say what the vector is. Okay, so reflect the shape in the line x equals 1. Now this is your x-axis and this is your y-axis, so x equals 1 is right there. And the only line that you can do from that point, other than going across the x-axis, and it doesn't say the x-axis, is to go up and down. So x equals 1 is this line here. If you think about any coordinates on that line, the x-coordinate's always 1. So that's our reflection line there. Now we're going to reflect it in that line, which is quite nice and easy to do. Pick a point, and we go 1, 2 to the line, so 1, 2 away, and just follow that process for all the points. So picking this point, that is 4 away, so another 4 away gets me to there, and the same one at the top, that's 4 away, and 4 away gets me to there, and then just joining it all in, obviously using a pencil for this one, and that would be my triangle. I haven't drawn that in particularly neatly, there we go. Okay, not forgetting as well, though, you could have a line, it could say the line, I don't know, y equals 3, which would be across at y equals 3, which would be across here. There's another couple of lines that we could have as well. We could have this one, y equals x. The line y equals x is the diagonal line here where all the x and y coordinates are equal. So we could have that one as well, where we have a diagonal. There's one more that we could have as well. Let's pick a different colour for this. We could have y equals negative x, which is very similar to the one above, but it's pointing in the opposite direction. And if I do that in blue as well, that's going down this way. So we could also have to reflect in a diagonal line. But again, you just follow the same process, counting diagonally. Okay, so rotate the shape 90 degrees clockwise about the point -1, 0. So first thing to do is obviously to locate that point, which is -1 across, not up and down, so -1, 0 is just there. The next bit, this is a lot easier if we have some tracing paper. So you stick your tracing paper nice and flat over your shape, trace it in, so trace over your shape, stick your pen on that rotation point and just rotate the tracing paper, not moving it away from the pen. So we would rotate it 90 degrees, so it would be facing this way and just making sure it stays nice and flat. And it would rotate the shape, let's have a look, it would go to here on your tracing paper, and then you would just lift your tracing paper up nice and carefully and draw it in at that spot. And again, the same process if you have to describe one of these, you stick your tracing paper over the top and just move your pen into different points, picking places like here and moving it around until you get the one that matches when you swizzle your paper around 90 degrees. And remembering obviously in your description you need to put the amount of degrees, the direction that it's gone in, and that rotation point along with the words rotation. Okay, so enlarge the shape by a scale factor of 2 from the point -4, -3. So let's identify that point first, -4, -3, and then we're just going to enlarge it by a scale factor of 2. So what I do is I pick a point on the shape, normally the closest one, let's say this one here, and I just think, right, how do I get there from the point? So we go 2 across and 1 up. And I'm just going to do exactly the same again. So 2 across and 1 up. And that there is a scale factor of 2. The first movement to the shape is my first scale factor, the second is my second scale factor there. So if I had a scale factor of 3, I'd do the same again. I'd go 2 across 1 up, and that'd be a scale factor of 3. But this one has just said a scale factor of 2, so I'm going to leave it there. Now if I have a look at the shape that's drawn originally, it's 2 along and it's 3 up. And this is going to enlarge it by a scale factor of 2, which doubles those numbers. So it's no longer going to be 3, it's going to be 6, and it's no longer going to be 2, it's going to be 4. So from this point here that we've got to, all I need to do is redraw that shape in, remembering it was the bottom left corner, this one here. So we'll just need to go 4 across, 1, 2, 3, 4, and 6 up, 1, 2, 3, 4, 5, 6. And then join it all up, nice and neat with a pencil and a ruler, and there it is, enlarged by a scale factor of 2. Just remember, if you have to describe one of these, it's a really nice way of doing it as well. You just pick the 2 corners, get your ruler and a pencil, join them up really nice and neat, pick another one, match it with the appropriate one, and then again join that up really nice and neatly, and it will show you down here, look, where that enlargement point came from. And you can find the scale factor by just looking at the sides. So the side length is 6 here, and the side length is 3 there, and 6 divided by 3 gives us a scale factor of 2. So if it was already drawn in, we found our enlargement point, we just say it's an enlargement, a scale factor 2, and from this point down here, just like it did in the question, enlargement, scale factor 2, and from this particular point. Okay, so the probability that Amy wins a game of snooker is 0.2. Amy's going to play 2 games of snooker, work out the probability she wins exactly 1 game. Now let's have a look at this one. So if we create a probability tree for this, we've got on that first game, which I'll label this branch as the first, she either wins or she loses. And the probability she wins is 0.2, and the probability that she loses is 0.8. Now she's going to play a second game, so I'm going to have a second branch. Again, this is after she's won, and we've got a second branch here in case she loses. But again, she wins or she loses, and she wins or she loses. Now it doesn't say the probability changes on the second game, so it's all just going to be the same. 0.2 for a win, 0.8 for a loss, and the same below. 0.2 for a win, 0.8 for a loss. Okay. So it says work out the probability she wins exactly 1 game. So she wins exactly 1 game, that's quite important there. Now the only way that she wins exactly 1 game is if she also loses a game. So this win-win up here is no good, and this lose-lose down here is no good. But here we've got the probability of a win and then a loss, and then here we've got the probability of a loss and then a win. All we need to do is work out these 2 probabilities. So to get to this second branch here, if we go to the start, we go up through the win and down through the loss. So that's 0.2 multiplied by 0.8. And 0.2 times 0.8 is 0.16. Looking at the second option there, she could lose and then win. And that just goes through 0.8 multiplied by 0.2, which gives us the same answer there of 0.16. So we've got our 2 answers there. We've got 0.16 for that route and 0.16 for that route, and when we've got 2 probabilities to combine, we just add them both together. So 0.16 add 0.16 gives us a total probability there of 0.32 as our final answer. So another probability question. James takes the bus to school. The probability his bus is late going to school is 0.3, and the probability his bus is late going home is 0.7. What is the probability that at least one of his buses is late? Let's have a look at creating a tree. So this time it's not the same thing on both occasions. We've got one where he's going to school, and the other part of the branch is where he's going home. But when he goes to school, it's either late or it's not late. And the probability of late is 0.3, so therefore the probability that it's not late is 0.7. Then we've got the next branch, which is going home. Now the numbers look quite similar here because we've got 0.7 in there again, but we've got late and not late, and again late and not late. But this time it says going home, the probability that's late is 0.7, so this would be 0.7, and again 0.3, and the same below, so 0.7 and 0.3. Now the question says to work out the probability that at least one of his buses is late. So this time it's not just one late, it could be late on both. So we could have the probability, let's do this in a different colour, we could have the probability that it is late and then late. We could have the probability that it is late and then not late, that's at least one, and the probability that it is not late and then late on the second one. But not late on both is no good to us, so we don't want that one. So what we need to do is work out these three probabilities this time. So late then late goes through 0.3 and then 0.7, which is 0.21. We've got the probability of it being late then not late, which is 0.3 times another 0.3, which is 0.09. And we've got that third one there, okay, which is not late and then late, which is 0.7 times 0.7, and that equals 0.49. So this time we've got three probabilities to add together, but because we've got a combination there, again, we just add them all up. So 0.21, 0.09, and 0.49. And altogether that adds up to, let's have a look, 8, 9, carry the 1, 4, 5, 6, 7. So 0.79 is our final answer for this one. Let's have a look at some with some fractions. Okay, so this question here says Mary has 2 bags of counters. In bag A there are 3 red and 2 blue, and in bag B there are 4 red and 3 blue. It says Mary takes at random a counter from bag A and notes its colour. She then takes at random a counter from bag B. Work out the probability that Mary takes the same coloured counters. Now again, this is an independent event because they're 2 different bags. It doesn't matter whether we take a red out of bag A, that's not going to affect the probability in bag B because that's a completely separate bag. So again, we can construct a tree for this. Now it starts talking about bag A, so I'm going to start with my tree being about bag A, and I'm going to label that up here, bag A. There we go. And again, it's red or blue. Now I've decided to stick with red and blue counters for all of these questions here, but there could be any sort of different combination of counters or pens or anything, or marbles it sometimes goes on about. We just need to make sure we read the story and construct our tree. So for red, there are 3 reds and there are 2 blues. That's out of 5 in total. So for red it's 3 out of 5. And for blue, again, it's 2 out of 5, remembering obviously that those numerators have to add up to 5 in this scenario if you weren't given the information. So that's our pick out of bag A, and then we've got to have a look at bag B. So again, I'm going to label the second branches of the tree over here bag B, but again we have 2 different scenarios. Now we could take a red, in which case we're looking at this part of the tree, and again it's a red or a blue. And in that second piece of information there, let's highlight that, there are 4 reds and 3 blues. So there'd be 4 out of 4 plus 3 is 7, so 4 out of 7 this time, and it'd be 3 out of 7 for the blue. Of course, we could have taken out a blue out to start with, so we could be on this part of the journey, and again, there'd be a red or a blue, but nothing's going to change down there. It doesn't matter whether we take a red or a blue out. Red and blue are going to stay the same, so it's still going to be 4 out of 7 and 3 out of 7. And there we go, that's our tree constructed. And again, just thinking about obviously those second little sets of branches there, both are the same top and bottom, as it's an independent event, and it doesn't say anything changes. You know, it might say if so-and-so took a red in bag A, that the probability changes in bag B. If it doesn't state anything though, we always just assume that it's always going to be the same there, as it doesn't say anything's going to change. So it says here, work out the probability that Mary takes the same coloured counters. So again, just thinking about the logic here, like before, we had red, blue and blue, red for different coloured counters. This time it's the same coloured counters, and there are 2 ways of doing that. We could get a red going through the 3/5 there, and another red going through the 4/7. So that is our 2 fractions that we're going to have to multiply this time. So if we do those, we get 3/5 multiplied by 4/7, and again, times in the top gives us 12, and times in the bottom gives us 35. So there are 12 out of 35 ways of getting 2 reds. And then obviously thinking about the fact of the same colours, we could have 2 blues. So if I go through blue, 2/5, and through the other blue, 3/7, that's going to give us our second probability there using those 2 fractions. So if we write those down, we have 2/5 multiplied by 3/7, and that gives us 6 on the top and 35 on the bottom. So telling us there's 6 out of 35 potential ways of getting 2 blues. And again, finishing this question off, we've got 2 probabilities that we need to add together. So I'm just going to write down the sum this time. We've got 12 out of 35 and we need to add to that the 6 over 35, and 12 plus 6 is 18, and that is out of 35, again remembering not to add the denominators together there. So 18 out of 35 is going to be our final answer for this question, as our probability of getting the same colours. Remembering again though, you could get a nice easy one. It could say what's the probability of 2 blues, in which case we'd have just gone along that purple route and got 6 out of 35. Okay, so just thinking about obviously the slightly harder style questions here rather than just one straight route. Okay, so if you're able to do these, you're able to do most of those questions there. Okay, so when looking at mean, median and mode, we could just have this from a list of numbers. Now, no matter what list of numbers you're given and whatever averages you're looking for, it's always best to write them in size order, as that's going to help with most of the averages. So if we have a look at writing this in size order, we've got 3 as our smallest number, so we'll put that first. Then we have 2 4s, so we'll write them next. We have 2 5s, and let's see, we've got a 6. We've got an 8, and then we have 9 and 10. Now that's not necessarily going to help you with working out the mean, but it is going to help with part B and C where we're looking at the median and the mode. So to start with here, we're going to actually just work out the mean. Now if we add these all together to work out the mean, we get a total of 54. And when we're working out the mean, once we have the total, we just have to divide it by however many numbers there are. So if we count, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, so there are 9 numbers, so we do 54 divided by 9, and we get an answer of 6. So the mean in this question is just going to be 6. To work out the median, we need to find the middle number. Now hopefully we just get 1 in the middle, but we'll talk about what happens if we don't. But let's just cross off numbers from either end. And let's see if we get a number in the middle, 1 more on each side, and we do, we get a median of 5. So this particular question just has a median of 5, and that's why we've put it into size order, so we can apply that method. Now if you do get 2 numbers in the middle, so say for example there was a 5 and a 6 in the middle and there was 2 left, you would just add them both together and then divide by 2, essentially finding the mean of 2 numbers. So add them together and divide them by 2, but obviously in this question we did end up with a number in the middle. Now we've got to work out the mode, and this is where I prefer actually underlining the numbers rather than crossing them out, because now we have to work out another average. So really I'm going to have to look behind all those crosses. Now thankfully I can just get rid of them, but obviously if you're in an exam you don't really want to be scribbling all over the numbers, so I would opt for underlining them if you have the choice. So looking at this then, we need to find the mode. Now you can see that there are 2 4s that are grouped together there, but there are also 2 5s. So there's not just one mode for this question, there's actually 2. So we would say 4 and 5 for this particular question, although usually when you are asked to work out a mode, there's normally only 1, but just in case there isn't, you can have 2. So there we go, that would be looking at just working out averages from a list, but of course you need to remember that you could be asked to work out these averages from a table as well. Okay, so we're going to start by having a look at averages from a table. So this table shows the mark for 30 students in a test, and it wants us to calculate the mean and write down the modal mark. Now to calculate the mean, it's quite nice and simple. If we have a look at this table here, this first row says that there are 2 14s, and if we add together 2 14s we get 28, so we can just times these together to find out what the total is. So that's 28. 10 15s times those together is 150. 2 16s is 32. 3 17s we'll have to work out, I think that's 51. 3 times 17 is 51. And the last one there is 13 times 18, so 13 18s is 234. Now if we add all this up, it'll tell us the total amount of marks that everybody got. So 234 plus 51 plus 32 plus 150 plus 28 gives us a total amount of marks there of 495. So that's their total, and it says that there are 30 students up here. Although if we didn't know that, we could add together this frequency column and we get a total of 30. So to find the mean, we just need to do 495, the total amount of marks, and divide it by 30. And that gives us a final answer there of 16.5. And don't forget, your answer has to fall in between the range here, which is between 14 and 18, so 16.5 is within that. It makes sense, we're happy with that. Now part B says to find the modal mark. Now the modal mark just means the mode mark, okay, the one that's the most common. And if we have a look at our table here, the one that's the most common is this one down at 13, and that represents 18 as the modal mark. So the modal mark would be 18. okay, because 13 people got that, and that's the highest there in that frequency table, so 18. Now this question is very similar. It shows the height of 30 students. It says calculate an estimate for the mean, and then again write down the modal class interval. So the reason it says to find an estimate for the mean is because we can't get an exact mean because we don't actually know, particularly looking at just this first row, what that person's height actually is. It's one person between 130 and 140. There could be anything, 132, 138, anything in between. So what we do is we pick the midpoint. So in between 130 and 140 is 135, and we're just going to use that as an estimate for the height of that person. And we'll do the same for all the others, 145, 155, 165 and 175. And we'll just treat this in exactly the same way as we did before. So one person at 135, 7 people at 145, and we're just going to times across for all of these again. So one lot of 135 is 135, 7 lots of 145 is 1015, again I'm just doing this on the calculator, 8 times 155 is 1240, 10 times 165 we can do 1650, and 4 times 175 gives us 700. And again, from here, it's just the same process. We add those all together. So 700 plus 1,650 plus 1,240 plus 1015 plus 135 gives us a total there of 4,740. And again, it said that there were 30 students there, which we can find from the bottom. So finishing the sum exactly the same as before, 4,740 divided by 30 will give us an estimate here for the mean, because again we have just guessed what their heights are using those midpoints, which gives us 158. And again, that answer there has to fall in between this range here, which starts at 130 there and ends down here at 180. So it has to fall in between, so 158 centimetres. Now the next bit says write down the modal class interval. Now the word class just means group, so it's the modal group, which group is the most common, and that's here with these 10 people. So all I have to do is, and I've written over the top of it now, but all I have to do is write this group down here. So the modal interval, okay, is that exact thing there, and I just write it down word for word, 160 to, what was in the middle, h in this instance, to 170. And that would be my modal class interval just there. Okay, so the last one of these before you have a go. It says on an activity day, students play one sport, either football, hockey or tennis. And it said there are 120 students, 30 are boys, 12 of the 38 students who play hockey are boys, 35 of the 45 students who play football are girls, one of the girls is chosen at random, write down the probability to play tennis. So this is very similar to our last one in that we're going to have a very similar table. Okay, we're going to have a nice table drawn out. We've got boys, we've got girls, and we've got a total, which I'm now just going to label as T. Okay, you can write the full words in if you want. And then I've got 3 options and a total at the end. So we've got football, we've got hockey, we've got tennis, and again a total. And then I'm just going to label that as total, as I've got another T up there. Right, okay, so putting all the pieces that we've got there are 120 students. So let's put that in our total down there. It's 120 in total. We've got 30 of the students are boys. So in the boys column, total is 30. The next one there, we've got 12. Let's have a look. This has got 2 bits of information here. Look, it says 12 of the 38 students who play hockey are boys. So that says 12 of the people that play hockey are boys, and that's out of the 38 that play hockey. So 12 are boys. Let's have a look for the hockey column. 12 boys out of 38 down there. And we've got the same piece of information here with the football. It says 35 of the 45 who play football are girls. So in the football column, we've got 35 are girls out of the 45. There we go, so that allows us to put 2 bits of information in. So now we can go about actually filling in the rest of this table. So let's have a look then. We've got the first column there, that has to add up to 45, so we're missing 10. So we've got 10 boys. I'm then going to go across the top here. So at the moment, along these 2, we've got 22 so far. We need to get to 30, so that's an extra 8. Let's have a look where we can go now. We can go down this way as well. Okay, we've got 30 boys, so that's going to be 90 girls to make sure it adds up to 120. And where else can we go from here? We've still got this missing box here as well. So at the moment, these 2, what do they add up to? We've got 40, 50, 60, 75, 83. That adds up to, we need to get to 120. So that is going to be an extra 37. And then we've also got the one above that now, and obviously these 2 in the middle. So moving down this way, we've got 12 there. We need to get to 38, so that's an extra 26. And we've got 8 here. We need to get to 37, so that's an extra 29. There we go. And as I said before, just a quick check that these still add up to 90. So 35, add 26 is 61, plus the 9, 70, 80, 90. Yes, that all adds up, so that's absolutely fine. Right, there we go. So that's our table filled in. And then let's have a look. It says one of the girls is chosen at random. Okay, so one of the girls is chosen. Write down the probability that they play tennis. Okay, so the language is different here, and this is important. It says one of the girls is chosen. So if we have a look, how many girls are there in total? There are 90. So one of those 90 girls is chosen. So our probability this time is going to be out of 90. Just got to watch out for the language there. What's the probability that they play tennis? Well, there are 29 there that play tennis. So that's going to be 29 out of 90. Okay, so obviously the language is different there. It said one of the girls is chosen, so that specifically, that dictates that you are having to choose from one of the 90 girls, and then out of that 29 of them play tennis. There's our probability. And again, as with all probabilities, you do not have to simplify that. You can just leave it as it is. Again, it's an important piece of information there. It tells us specifically that 29 out of 90 play. Not that that one does simplify, but if it does, you don't have to simplify it. Okay, although you wouldn't be wrong for doing so, but it's just going to waste a little bit of your time. If you're only going to watch one video this year, this is the one. With GCSE Maths right around the corner, I'm going to show you 3 easy steps to maximise your grade using minimal effort. Step 1. Head to the TGMT hub, go to the bottom of the page once you've logged in and access the revision quiz. From here you can answer a question on every topic within the GCSE. You can go through working through each question and making sure that you practice absolutely everything. Once you've done that, you are going to get a full report that shows you exactly what you got right and wrong on all of these questions. So work your way through the quiz and then access your report. From here you can see on individual units what you need to work on and what you've already secured. So identify what you need to work on. Then we're on to step 2. Head back to the hub. You can go through the units, you can go to the exact one that you know that you need to work on, and you can access all the individual topics within that unit. Once you've done that, you can pick the topics that you want to work on, watch the video, and you can complete a topic quiz for that particular topic. So work your way through the quiz, answer those questions, and then you're going to get another report. That's going to show you exactly what you got right and wrong, so that you know if you need to do any more work. Step 3. Head back to the hub and go to the bottom. You can now go onto the upgrade quiz. On here, you're going to be able to answer questions again, different to the first, on every single topic within the GCSE. Once you've done that, you're going to get another quiz breakdown and a report that shows you exactly what you got right and wrong, so you can put any of those finishing touches in before that exam comes along. With the exams right around the corner, we need to make sure that we make revision simple. Join upgrade. Okay, so when looking at order of operations, we can have certain different types of questions, and this one here we've got 2 parts. So here it says work out 4 plus 7 times 5. Now if we were to follow our order of operations, we would do the multiplication before the addition. So we want to bucket off these 2 and make sure we do the 7 times 5 first. So actually this calculation will say 4 plus, and then 7 times 5 is 35. So we've got to do 4 plus 35, which would give us a final answer of 39. Now in this part B where we're putting brackets in, normally that just means that we're going to have to put the brackets round the pieces that we wouldn't normally do first. So in this calculation, without any brackets, we would normally do the division first, and that would give us 15 add 2, and that would give us an answer of 17. And it wants us to put the brackets in here so that we get an answer of 5. So our only option is to put the brackets around the 15 plus 10. But we'll put the brackets in, we'll make sure that that works, and then we'll check our answer. So 15 plus 10 would be 25, and because the brackets are there, we would then divide the answer by 5, and 25 divided by 5 does equal 5. So that works, and our brackets would go around the 15 plus 10. Now when we're working out a fraction of an amount, we just need to have a look at that denominator. If something is being split into thirds, it means it's going to be split into 3 different parts. And if we were to draw this, and I'm only going to do this for this first example, but if we were to draw a little example with a little bar, if we were to split this bar into 3 portions, there we go, and I've not drawn it perfectly, but they should be equal parts, then that would be splitting something into thirds. So if we were going to figure out what number was going to go into this bar, bearing in mind we're splitting 48 into thirds, then in order to do that I would divide by 3. So to start with, I would do 48 divided by 3, and I just need to work out what that is. So if you need to, you can obviously do some division to the side. So I would go for bus stop division if you didn't know what this was off the top of your head, and we'll do 3's into 48. 3 goes into 4 once with a remainder of 1, and it goes into 18 6 times. So 16 would be each of our 3 parts. So if we put the 16 into each of our bars, that would be splitting it into 3. Now this question only wants to know what 2/3 are. So out of those 3 parts, we're only actually looking at 2 of them. So I would take my 16 there, find the total of the 2, or in other words, I would do 16 times 2. So in terms of just working out the numbers, we've got 48 divided by 3, which is 16, and that is equal to 1/3. So 1/3 would be 48 divided by 3. And then for our 2/3, which is what we are looking for, we'd take that 16, multiply it by the 2 parts we're looking at, and we'd get an answer of 32. And again, we could label that on the diagram just there as 32. So thinking about what we've done here, all we've actually done is looked at the denominator, and we've established that it's going to be split into 3 parts. So to do that, we've divided by 3, just here, divide by 3. And then because we want 2 of those, again, just looking at the numerator there, we've multiplied our answer by 2, and we've got a final answer of 32. Now when we're looking at this sort of question here, one thing we need to remember, no matter which type of calculation we're doing, adding, subtracting, dividing or multiplying, if we have mixed numbers involved, we need to make them top heavy first. Now when it comes to adding and subtracting, there is a little bit of a different approach that you can take that some of you may use, but I'm going to use the same method for all of these types of questions, and that is making any mixed numbers top heavy fractions first, or improper fractions first. So the process for doing that is obviously taking our fraction here, 3 4/5, we want to turn that into an amount of fifths. So to do that, we want to figure out how many fifths are in 3. So we can do 3 times 5, which is 15. Add the extra 4/5 there, and that makes 19 fifths. So 3 4/5, 3 times 5 is 15. Add the 4 that we've got there as well is 19 fifths. Okay, so it's the big number times the bottom to make 15, add the top number on the fraction there, 19, so we've got 19 fifths. And we're going to add that to the 3/7. Now when it comes to adding and subtracting, we need to have a common denominator. So we need that number on the bottom to be exactly the same. Now that means that we can multiply both fractions here. As long as we should do whatever we do to the bottom, we also do to the top. We can make equivalent fractions with a common denominator. So thinking about 5 and 7, the lowest common multiple of those is 35. So in order to get them to be 35, the left fraction there, I can times the top and bottom by 7. And the right fraction we can times the top and bottom by 5, and that would give us 35 on the bottom of both. So we've still got to work out 19 times 7 there, and obviously take your time doing so, but 19 times 7 is 133, and at the moment that is going to be over now 35. Okay, so you get some quite big numbers here, but obviously don't be afraid just to the side to do some multiplication there. I did 7 times 10, and 7 times 9, and added them both together, okay, but you can show you working out to the side. On the right fraction there, we're going to times them both by 5, so 3 becomes 15, and 7 becomes 35. And now we're in a position where we can add these both together. So we can just add together the numerators, 133 plus 15, which gives us 148, and that is over 35, remembering that you don't add together the denominators. There we go, we've got 148 35ths. Now obviously it says here to give your answer as a mixed number in its simplest form. So it's up to you whether you try and simplify this or whether you obviously turn it into a mixed number first, but we need to turn it back into a mixed number. So to do that I need to know how many times does 35 go into 148. That's not the nicest, so I'm just going to write down a few of the 35 times table. So 35, add another 35 is 70, add another 35 is 105, add another 35 is 140, and then it's not going to go beyond 140 there, because obviously our number there is only 148. So to go from here, we know that 35 goes in 4 times, so that's going to be a big 4. And what's left over from 140 to 148 is an additional 8 35ths. There we go, so 4 and 8 35ths left over. Okay. Okay, so just these two for converting a fraction. Now the first one here is quite a nice one, and you might already know what that is as a percentage, and that's fine, but we're going to have a look at the method for going about it. So when we have 1 over 4 and we want to write it as a percentage, not forgetting that that word percent means per 100, we want that denominator to be out of 100. Once it's out of 100, we can see what it is out of 100, and then we can write that percentage. So first of all, we need to think to ourselves, what do we multiply 4 by to actually get to that 100 on the bottom? And hopefully you can spot that that number is 25. Of course, if you're not sure, you could do 100 divided by 4 and some working out to the side to figure it out. But remembering whatever we do to the bottom, we have to do to the top. So 1 times 25 on the top gives us 25. Now it is a fraction over 100. Per 100, it's 25 per 100. So that will equal 25%. And there we go, we've got our percentage. So our process for this is to turn our fraction out of 100 and then basically just reading the numerator. For our next question, it does say to write it as a decimal. So to write it as a decimal, we'll first turn it into a percentage. And then again, once it's a percentage, we can just hop the decimal before it and divide by 100 to get our decimal. So for 3 over 5, again, we just need to spot what are we going to multiply the denominator by to make it out of 100. And that number that we need to multiply by for 5 is 20. Again, you could work that out, but if we multiply the top by 20 as well, 3 times 20 is equal to 60. Now that's 60 per 100, so that is equal to 60%. But of course we want to write that as a decimal, so if we hop our decimal in 2 jumps by dividing by 100, then that is going to give us a decimal which is 0.60. Of course you don't need to put the 0 at the end, so you can just write that as 0.6, but of course it wouldn't be wrong to write it as 0.60, but our final answer for this one is 0.6. Okay, so when writing decimals in order of size, we want all the decimals to have the same amount of decimal places. So if we look, our largest amount of decimal places is 3, and that's in this one and this one. So the 0.4 I would normally write as 0.400, and I'd also write the 0.35 as 0.350. Then we just ignore the 0 point and we'll just read the numbers after it. So we have 354, 400, 350 and 345. So the smallest number is going to be the 0.345, so we'd write that down. The next smallest is going to be the 350, which is the 0.35, so that would go next. Then we have 354, which is the 0.354, and then to finish it off we've got the 0.400, which is 0.4. And notice how I also wrote the original decimals back in and got rid of those additional zeros that I put. Okay, so in this question we've got a list of numbers. We're going to write down a prime number, and we're also going to write down a cube number. So for the prime numbers, we've got a few different options here. Well, 2. The first and only even prime number is 2. So for the prime numbers, we could write down 2, and we could also write down 5, remembering that prime numbers are numbers that can only be divided by themselves and 1, and therefore they only have exactly 2 factors, which is the reason why 1 is not a prime number. So for this answer here, we could say 2, or we could say 5, but it only says to write down a prime number, so we'd only write down one of those. For the next one, it says to write down a cube number. So a cube number is found when you times a number by itself for 3 times. So for example, we could do 1 times 1 times 1, and the first cube number is 1. So therefore we could have 1 as a cube number. To recognise the rest, you'd kind of just have to do the calculation unless you already recognise them. But there is one more on here, and that is 3 times 3 times 3, which is 27. So 27 is also a cube number, and we have that in our list as well. So that's how you work out a cube number, and if we write one of these down, we would write down either 1 or 27, and again we'd just pick one of those and write them down as our cube number. Okay, so when looking at rounding to a certain amount of decimal places, this first one here says to round to 2 decimal places, so we would put a rounding line after that second decimal place. So it's either going to be 3.04 or it's going to round up to 3.05. In this case, there's a 5 after the line, so that's going to round up and it's going to be 3.05. And that would be our answer. Remember that when you're doing your rounding, it's either going to stay as it is or it's going to round that very last number up. Now this second one here says to round to 3 decimal places. This is quite a unique one. If we stick our line after the 3rd decimal place, you can see that there's a 6 after the line, so it is going to round it up. But we have 8, 5, 9 there. So because there's a 9 before the line, that's going to make it round up to 0.860. And then we could write that out like that, 0.860, that rounds the 59 up to 60. And because it said 3 decimal places, in this particular example, we'd actually leave the 0 in there, because that would actually keep it to 3 decimal places, even though the answer's 0.86 is exactly the same. If it asks us to write it to 3 decimal places, we'd keep that 3rd decimal, even if it's a 0. Okay, so when looking at inequality notation, we could just have to put some inequality symbols within these brackets or in these squares here, just to make sure that we are saying whether something is greater than, less than, or in this case we've also got equal to. So for this first one, we've got 13 and 25. Well, 13 is less than 25, so we would say less than in our box. For the next one, we've actually got to work this out. So 4 plus 9 is 13, and 102 take away 89 is also 13. So those two are equal to one another. For the next one, we've got 4 squared, which is 4 times 4, which is 16. And on the right there, we've got 4 times 2, which is 8. 16 is greater than 8, so we would say 16 is greater than 8, putting in our inequality symbol. And for the last one here, we've got -5 and -3. -5 is less than -3, so we would say less than -3. And there we go, that's using some inequality notation. Okay, so this question says on Monday, Alex earned £120 and she worked for 8 hours. Work out Alex's hourly rate of pay. Well, if she worked for 8 hours and earned £120, if we do 120 and divide that by the 8 hours, that's going to tell us how much she earned for every 1 hour. And that comes out as £15. So Alex's hourly rate of pay is £15. For the next part of the question here, it says on Thursday, Alex earned £120 and on Friday she earned £100. Alex earned the same amount of money on Monday, Tuesday and Wednesday. She earned a total of £550 for these 5 days. How much did Alex earn on Monday? Well, she earned the same amount of money on Monday, Tuesday and Wednesday. So let's work out how much she earned in total over those 3 days. So on Thursday and Friday, combined, she earned £220. Okay, £120 plus 100. Now, if we take that away from the total amount that she earned, which was £550, we'll know the total that she earned on Monday, Tuesday and Wednesday. So 550 take away 220, and that leaves us with £330. Now, because she earned the same on Monday, Tuesday and Wednesday, we can divide that by 3, which would perfectly split it into those 3 days, and you'll see that comes out as £110, and there we go. That would be our final answer. So she earned £15 per hour, and on Monday, Tuesday and Wednesday she earned £110, so on Monday it was 110. And he only has caramel, orange, coconut and strawberry flavoured chocolates. 2/7 of the chocolates are caramel, 35% of the chocolates are orange, and the ratio of the number of coconut to the number of strawberry is 4:5, and it wants us to work out the number of coconut chocolates that James has. So let's have a look. We've got 2/7 that are caramel, and we've got the next bit of information there that tells us that 35% are orange, and then it goes on to tell us that coconut to strawberry is 4:5. So if we start with the first piece of information here, and that's that 2/7 are caramel. So to break this down, we'll start working out one of those pieces of information. So to work out 2/7 of a number, obviously you need to know how to work out a fraction of an amount here. We're first going to work out 1/7. And to get 1/7, we're going to divide 420 by 7. So obviously if you have a calculator, this sort of question is relatively simple in terms of the calculations, but if you don't, you're just going to have to do a little bit of bus stop method to the side and working out 7 into 420. So 7 goes into 42 6 times, with and then 7 doesn't go into 0 obviously, so we have 60 there. So 1/7 would be 60 chocolates. And obviously always leave your working out to the side. I'm going to get rid of that because we need the space, but obviously always leave your working out. Now we want 2/7, so we'll double that. So 2/7 would be 120. And then we've got our first piece of information. We've got there are 120 caramel chocolates. Now we can move on to the chocolates that are orange. So again, if we get rid of this and we'll just focus on the working out, in fact we'll just leave that there for the moment, we'll go with working out the 35% first. So to get 35%, again, if we'll assume that we don't have a calculator for this, we'll work out 10% and use our non-calculator method. So 10% is going to be 42, and 5%, which is half of that, is going to be 21. So in order to get 35%, we're going to want 3 of the 42s, that takes up to 30%, and then we'll add the 21. So completely up to you how you do that. You can either multiply that by 3 and add 21, or just to the side, again, always showing you working out, we could just add 3 of them together, and then add the 21, and add that all up. We get 7, and 4, 8, 12, 14, so we get 147. And then let's add that up here next to our information, and that is 147 orange chocolates. Now we've got one last piece of information, and we're going to get rid of all of this and just focus on that for now. So this last piece of information here tells us that the number of coconut to the number of strawberry is in the ratio 4 to 5. And that is going to be for the remaining chocolates after we get rid of the caramel and the orange. Okay, so we need to actually work out how many are left just for those. So if we add together the 120 and the 147, that adds up to a total of 267. Now we need to take that away from the total, and we know that the total was 420. So 420, and we'll take away 267, and again, without a calculator, we're going to have to do a bit of work here. 7 from 10 is 3. We're going to have to carry again. 6 from 11 is 5, and 2 from 3 is 1. So that leaves us with 153 chocolates that are going to be coconut or strawberry. So we're going to write this as a ratio. So coconut to strawberry, and that is 4 to 5. I don't always dislike that when there's an S and a 5 next to each other, they look so similar. So we've got 153 that we're going to share in that ratio. So 4 and 5 gives us 9 parts in total, and again this is sharing in a ratio. So again, if you need any reminders on how to share in a ratio, I'll put the link for this video in the description, so you can go have a look at sharing in a ratio if you need to. But let's share this 153. So we've got 153 that we need to divide by 9, and again, if we're not doing this with a calculator, we'll divide that by 9 and see what we get. So 9 goes into 15 once with a remainder of 6, and then 9 goes into 63 7 times, so that leaves us with 17. So for this, 1 part is equal to 17. So with our ratio, in order to turn these into the actual amount of sweets, we need to multiply them both by 17. So again, we can do 4 times 17, and again you can just multiply that to the side or add them up using column addition, but that is going to be equal 68. And if you do 5 times 17, that's going to equal 85. So there we go, that is all of our amounts there. If we apply that back to the question, underneath coconut there we've got 68, and underneath strawberry we have 85. Now the question here did only say work out the number of coconut chocolates that James has, so for our final answer we would say 68, as that was the amount of coconut that we had after we worked out that ratio. So there we go, there was a lot going on in that question. You had working out a fraction of an amount, a percentage of an amount, finding out what was left, and then sharing that in a ratio. Okay, so this question says increase 250 by 35%. So if we're increasing by 35%, then obviously we're going to start with a 1-point number. So we're going to have 1 point, and then for 35%, that would just be 1.35. And that would increase for us by 35%. The 1 represents the 100%, the extra 0.35 represents the additional 35%, so that increases it by 35% for us. So into our calculators, we just need to type in 250 multiplied by 1.35, and if we type that in, that comes out as 337.5, and that right there is our final answer. There we go. Again, just thinking about the logic here, when you multiply something by 1, it doesn't actually change, it just sticks as it is. So adding the extra 0.35 there is just adding on that additional 35% on top of the original number. So this method works very, very nicely. It's very, very quick, but you just need to be happy to convert back into the decimal there. And if you want to think about the logic behind it, 35% as a decimal is 0.35. Okay, but obviously we're changing it to 1.35 to incorporate the fact that we are going to increase it. Okay, so looking at a single digit percentage. Now we're going to decrease here by 4%. So if we want to know what percentage is left over, well, if we take away 4% from our original 100%, we would be left with 96%. So if we're going to decrease something by 4%, we actually are working out 96% of that number. And 96% as a decimal can be written as 0.96. So that is our multiplier that we're going to multiply by. So nice and easy, we get 240 on your calculator, multiply it by 0.96, and if we type that in, 240 times 0.96, the answer comes out as 230.4. And there we go, and that's our final answer. So to work out a percentage decrease, we figure out what percentage will be left over once that has been taken away, and then multiply by that decimal version, which we call a multiplier. Okay, so writing a ratio in the form n to 1. Now this one does have decimals. We've got 4.5 on the left and we have 2.25 on the right. Now no matter what the numbers are, if we want to get it to be 1 on the right hand side, then whatever is on the right hand side here is what we need to divide both sides of the ratio by. So in this one it is a decimal, 2.25, so we need to divide the right hand side by 2.25. And when simplifying a ratio, we do the same to the left. So we would also divide the left-hand side by 2.25, and we could just type that into our calculator. So 4.5 divided by 2.25 is equal to 2. So our ratio is 2 to 1, and that value of n is 2. So just think about that when you're writing a ratio as n to 1. No matter what is in that 1 position, that's what you're going to divide by. Okay, so this question says, here is a scale drawing of the plan of a room. Mr. Ahmed wants to put bookshelves along the complete length of the wall labelled bookshelves, which we can see just at the top here. It then says there are two sizes of bookshelves. Large bookshelves are 150 centimetres wide and small bookshelves are 100 centimetres wide. Work out how many large bookshelves and how many small bookshelves Mr. Ahmed can put along the complete length of the wall. There's going to be different options for that as well, I'd imagine. It says here that the scale is 1 centimetre and it's drawn on a little centimetre grid, represents 50 centimetres. So every single one of these boxes is 50 centimetres. So if we were to put, let's imagine the large bookshelves, they would take up 3 of those boxes. Because if we divide each of those by 50, that is going to equal 3 centimetres. And for the small bookshelf, if we divide that by 50, that's going to equal 2 centimetres. So if we put a large bookshelf here, 3 across, and then another large bookshelf, that leaves us with 2 as a gap at the end there. It has to go all the way along. So another 2 would be a small bookshelf. So that would be 3 large bookshelves. I'll just put 3L and 1 small one. Okay, and 1 small. But obviously there could be a different way of doing that. So let's have a look at another way as well. And let's start off by putting the small bookshelves in. So that would be 2 for a small bookshelf, another small bookshelf, another small bookshelf, another one there. And then there's a gap there of 3. So we'd want to put a large bookshelf in there. So for this one, or we could have 1 large bookshelf, and that's 4 small bookshelves. So they're the different options that we could use. Either one of those would be fine, but there we go. That's one of our options. It says both the large bookshelves and the small bookshelves are 50 centimetres from front to back. So they are 50 centimetres deep. Draw these bookshelves on the scale drawing to show how they will fit. But obviously you can choose any of the options above there. I'm going to go with this one. So 3 large bookshelves and 1 small one. So if we were to draw them in, that would be 1 bookshelf. That would be another bookshelf. There's our third. And then we'd have a small bookshelf at the end, and that would be showing those on the scale drawing. Right, so when it comes to a best value question, we tend to have 2 different offers in front of us, and we have to compare and we have to see which is going to be our better value, and not in terms of which is the cheapest at the moment, but which is the cheapest in terms of a single packet or a single gram or a single milliliter or whatever the type of item is that we're looking at buying. So on this particular question here, we've got some toilet rolls, and we've got 9 toilet rolls costing £4.23 and a 4 pack of toilet rolls costing £1.96, and we want to look at which gives better value for money, and we need to show our working here. Now when it comes to this one, we're going to find the cost of 1. So when it comes to our first option, and we've got a diagram over here, this is for 9, okay? So if we want to know the cost of 1, we just want to divide that cost by 9, okay? So in all of these questions here, when we're looking at best value, we get the cost of the item, and we just divide it by the amount, okay? Now, we don't really want to have to remember a formula for this, so I tend to think of a nice easy example. I tend to think, you know, if I have 2 apples for £1, okay, so let's just imagine this. I always think of nice easy little ways of remembering it. 2 apples equal £1, okay, what do you actually do there to get the cost of 1 apple? Well, you divide by 2, okay? You get the cost on the top there, you divide it by 2, so it's £1 divided by 2, and obviously that would give us 50p. Okay, so I've just obviously made that example up off the top of my head. It's one that I always kind of try and remind students of. Just think about a nice easy example no matter what, okay? So it's always going to be the cost divided by the amount. So we need to show all our working out for this. So for the first option here, I'm going to write out £4.23. Oh, that's not a 2, there we go, £4.23. And we're going to divide that by 9. So £4.23 divided by 9 gives me an answer, and it comes out as 0.47 or 47p. Doing the same for the other option, we've got £1.96. There we go, and we're going to divide that by 4. So £1.96 divided by 4 gives us the answer 0.49 or 49p. Okay, so from there, obviously we can identify which is the better value. We obviously want the one that's going to be 47p per roll rather than the one that's 49p per roll. So we just need to make a conclusion in this. We would say the pack of 9 is better value. Okay, so I'm just going to write the pack of 9. There we go, obviously back to by my working out there. Okay, so looking at writing a ratio as a percentage. It says here there are only red, yellow and orange buttons in a bag, and the number of red, yellow and orange buttons are in the ratio 7:9. Work out what percentage of the buttons in the jar are orange. Now in order to work this out, there are 2 different ways. First of all, we want to know the total in this ratio. So we've got 7, 4 and 9. Now the total there, if we add them all together, adds up to 20. So if they add up to 20, we could write all of these as a fraction. Now the orange is the 3rd number in the ratio, so the 9. So as a fraction, that would be 9 out of 20. Now without a calculator, you'd have to turn that into a denominator over 100, which isn't particularly difficult. But if we have a calculator here, we can just do 9 divided by 20. And you'll see that that comes out as 0.45. And in order to turn that into a percentage, you'd multiply it by 100, although I'd hope that you know that that is going to be 45%. But if you're not sure on that, you can always times the decimal by 100, and it will turn it into a percentage for you. So for this one here, that comes out as 45%. Of course, you didn't actually have to use your calculator. You could have just times the top and bottom by 5, which would have given you 45 out of 100, which hopefully you then would know would be 45%. Okay, so here's another question looking at ratios with percentages. It says here, Carl puts tins into small boxes and large boxes. The small boxes have 6 tins and the large boxes has 20 tins. He puts a total of 3,000 tins into the boxes, and then it tells us the ratio of small to large and says that it's 2 to 3. It says Carl says that less than 30% of the boxes are filled with less than 30% of the boxes filled with tins are large boxes. Is he correct? Well, let's actually work out how many tins are in each of the boxes. So if he puts 3,000 tins in total into the boxes, and that gives us the ratio of 2 to 3, then we can work out how many tins went into the small boxes and how many tins went into the large boxes. So just sharing that in a ratio. So in that ratio, there's a total of 5 parts. So if we do 3,000 and divide by 5, we know that each part is worth 600. So we have small to large, that is 2 to 3. So if we times both of those by 600, we'll know how many are in each one. So 2 times 600 is 1,200, and 3 times 600 is 1,800. So there are 1,200 tins in small boxes and 1,800 tins in large boxes. Now we can actually work out how many boxes there are that he's filled, because we know that there are 6 tins in each of the small boxes and 20 tins in each of the large boxes. So for the small boxes, if we divide this by 6, because there are 6 tins in each of those small boxes, so 1,200 divided by 6 would give us 200 boxes. For the other one on the right, I'm not going to write this as a ratio because we're not really working out a ratio here, we're just working out how many boxes have been used. Or we could think of it as a ratio of the boxes. So for the next one, we've got 1,800. There are 20 tins in each of those boxes. So if we divide that by 20, and 1,800 divided by 20 would equal 90. So there are 90 large boxes. So it says Carl says that less than 30% of the boxes filled with tins are large boxes, so we'd need to work out what percentage those 90 tins are out of all of the boxes. Well, there are 200 small boxes and 90 large boxes, so that is 90 boxes out of a total of 290 boxes. So if we do 90, divide it by 290 like that as a fraction, we get 0.31, and there are some more decimals there. I'm going to keep that as 0.31 because if we were to turn that into a percentage, that would already be 31%. So if that's already 31%, and we already know that Carl's statement is incorrect because it says Carl says that less than 30% are filled in the large boxes. So we've just worked out, well, actually, no, it's 31%, and there is a little bit more after that, but actually we would say no, Carl is not correct, okay, because it's over 30%. So we would make that statement, no, Carl is not correct. And there we go. So that wasn't the nicest of questions there, but another type of question that involved ratios and percentages. So this first one is 10 workers take 4 days to complete a job. How long will 8 workers take to complete the same job? Now, logically, we've got less workers, so it's going to take more time. What people are quite tempted to do here is to say, okay, well, 10 workers, 4 days, divide it by 4, working out 1 day, and then timesing it by 8. And that's completely wrong because that's going to give us a much lower number there than the 4 days. And logically, if we've got less workers, it's going to take more days, unless of course those workers are more highly skilled and they happen to take more obviously less days, but we're going to assume that it's the same type of workers here. We're going to talk about these assumptions as well in a sec. But having a look at this question here, we've got 10 workers take 4 days. Now if we imagine, and this is always the case, we've got to think, all right, well, if 10 workers take 4 days, how long would 1 worker take? Okay, and 1 worker would take 10 times longer, we would assume, okay, than obviously having 10. Just like if we had 2 workers doing a job, it would take them twice as long if it was just the 1 person. Okay, we times it by 2. So here, if we've got 10 workers taking 4 days, it would take 10 times 4, 40 days for 1 worker. Okay, and that is how long we would expect 1 worker to take. Okay, 10 workers take 4 days, so times that by 4, 4 times as long would be 40 days. And that's the first piece of information that we really need to work out here, because that's how long in days it would take 1 worker to complete this job. Now it says here that we've got 8 workers, okay? So we've got more than 1 worker, we've got the 8 workers. And if we've got 8 workers, we would assume it would be 8 times faster. So if we want to work out 8 times faster than 40 days, we can divide that by 8, and 40 divided by 8 would give us a total amount of days there of 5, so we would have 5 days to complete the job. Okay, so it's inverse proportion. Obviously we have more than 4 days there, we've got 5 days, it's taken longer, our answer makes sense, and we just need to think about the logic behind that there. Obviously multiplying it by 4, 4 times as long for 1 worker, but obviously for 8 work it would be 8 times faster, making that number, that 40 days there, shorter and down to 5. Okay, we are making some assumptions here. We are assuming that all the workers work at the same rate and they have the same skill. And obviously if this wasn't the case, our answer could be bigger, it could be smaller, but we don't know. Obviously more skilled workers, our answer could be smaller there, we could be less days, and less skilled workers, our answer could be bigger, it could actually be longer than 5 days. Okay, so let's read through this question. It says here that 5 boxes of cereal have a total weight of 1,750 grams. It then says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1,490 grams. Work out the total weight of 3 boxes of cereal and 2 sachets of sugar. So this question's different because we have 2 different variables. We have the cereal and we have the sugar. So we need to figure out one of them first, and let's have a think about which one we can work out straight away. Because that first line just says about one of the variables, it just says 5 boxes of cereal have a total weight of 1,750. So we can work out one of the boxes by dividing that by 5. So let's just have a think. We've got 5 boxes is equal to 1,750. So our first step to get the the weight of one box would be to divide that by 5. So we will divide it by 5 and we'll do our working out to the side. So 1750 divided by 5, well 5 goes into 17 3 times, remainder 2, goes into 25 5 times, and then 0 at the end. So the weight of one box is going to be 350. Of course this is in grams. And the final part of the question, which we don't have to work out straight away, but it wants us to ultimately work out the weight of 3 boxes. So straight away we could multiply this by 3, and again you could work this out at the end once you've got the singular weight for both, but we may as well just straight away times that. So 3 boxes, and that is going to be 3 times 350. 2 times 350 is 700, add another 350 is 1050. Again, you could spend some time just adding 3 of them together using column addition or multiplying it by 3, but there we go, we have the weight for 3. So let's get rid of this working out and move on to our next piece of information. So the next part is obviously we have the sachets of sugar. So for this second line here, it says that 4 boxes of cereal and 3 sachets of sugar have a total weight of 1490. Well, if we work out the weight of 4 boxes of cereal, as we know the weight of 1, then we could have a look at working out therefore what the weight of the 3 sachets of sugar are going to weigh. So if one box is equal to 350, 4 of those boxes is going to be 1400 grams. And obviously it says in the question that the weight, including the 3 sachets of sugar, is 1490 grams. So that is going to be adding another 90 grams. So those 3 sachets of sugar are equal to 90 grams. So we can write that down. So 3 sachets is equal to 90. Of course, we want to break that down and go back to 1 sachet. So we can divide that by 3. So if we divide that by 3, we're going to get that 1 sachet is equal to 30. There we go. And obviously the question here, and we'll swap colour again, wants us to work out the weight of 2 sachets of sugar. So we can straight away multiply that by 2. And if we multiply that by 2, we're going to get that 2 sachets is equal to 60. And that is the second part of our answer. Now, of course, this question here said work out the total weight of 3 boxes and 2 sachets. So we're going to want to finish this off by writing the total weight. And that is to take our 1050 and our 60 and add them together. So for our final answer, we'd do 1050 plus the 60, and that is equal to 1110. And that is in grams, and that is our final answer. Okay, so 2x plus 9 equals 16. Now taking the same approach here, we'll take away the 9, so minus 9, and we get 2x equals, take away 9 from 16, leaves you with 7. Okay, so the first thing you might be noticing here is, oh well, hold on, 7 doesn't divide by 2. Well, it does, it's just not going to give us a whole number. So we'll take the same approach again, we'll divide by 2, because we've got 2 times x here, so divide by 2, and we get x equals 7 over 2, and that's fine just to leave that as a fraction. Now obviously when it does simplify down, I would advise you go for it. Okay, 2 goes into 7 3 times, so we have 3 and 1/2 left over, or you could write your answer as a decimal, you could write 3.5, but it's perfectly fine for you to just leave your answer as a fraction and then write it as a mixed number, or simplify it in any way that you think is appropriate for that type of question. Okay, so 2x minus 2 equals 7x plus 8. Now this time the smaller value of x is on the left hand side. That's fine though, we'll just get rid of 2x. Okay, on both sides, and we'll see what we've got. Now when we do this, you've got to be careful because this is negative 2, which is going to be left here. So that's going to be negative 2 on the left, and it equals 5x when we take away the 2 plus 8. Okay, so we've got the x's on the right hand side, so we want to get rid of this plus 8. So to get rid of a positive 8 there, we're going to subtract 8, and do that from both sides. Negative 2 take away 8 is negative 10, so negative 10 equals 5x. And then finish it off just like normal, we're going to divide by 5. So divide by 5, negative 10 divided by 5 is negative 2, so negative 2 equals x. Okay, and it doesn't matter which way it's written around, we can just rewrite that if you want, x equals negative 2. And there's our final answer there. So we can have fractions, we can have negative numbers, we can have whole numbers, okay, but ultimately we just need to make sure we get the x's on one side, the numbers on the other, and then just make sure we solve it just like a normal equation there. Okay, so simplify this. 15 minus 4x minus 9 plus x. Let's have a look at what we get here. So the numbers I'm going to start with first, as is a number first, although you don't have to. So I've got 15 and a minus 9. And 15 take away 9 is 6. Positive 6, so I'll just write 6. Okay, so that's what those two came down to make. Now I'm going to look at the x pieces here. We've got negative 4x, add x. Now if there's not a number in front of it, that's 1x. So we've got minus 4, add 1. Minus 4, add 1 is minus 3. So minus 3x is there. And as it is minus, I need to make sure I emphasize that it is negative. So negative 3x. And we get 6 minus 3x there as our final answer. Okay, so if you rewrite this, you can put little circles or little boxes around the pieces, but just make sure you have a look at what symbols are in front of them, if it's positive or negative, and make sure that they go alongside that piece. Okay, so expand and simplify this. Now I've got this minus 2 in the middle here, so we just need to be careful, but let's just treat it in exactly the same way. We'll times the first bracket by 3 to start with, so 3 times 2x gives us 6x. And 3 times negative 4 gives us negative 12. Now let's have a look at that second bracket. So we have a negative 2 at the start here, so we're just going to have to remember to times by negative 2. So negative 2 times x is negative 2x. And negative 2 times positive 5 gives us negative 10. Okay, so the symbol's not just getting copied there, it is getting affected by that negative 2 at the start. So be very, very careful with this negative 10 here when you're doing these. Right, so collecting it all together. We've got 6x, take away the 2x, and that leaves us with 4x's. And we've got negative 12 and negative 10 here. Negative 12 take away 10 is negative 22. And there's that expanded and simplified. Okay, so expand and simplify this one. So we've got a negative in the second bracket. So I'm just going to rewrite this. We just need to make sure we're careful with that. So x plus 5 and x minus 2. Now following the same process, I'm going to do the x times the x. I always do those first, get that x squared piece at the start. So we get x squared, and then the x times the negative 2. So being careful this time because it is negative 2, so it's going to be negative 2x. Okay, just be very, very careful of the symbols. Then onto the 5, it's positive 5 times x, so positive 5x. And then positive 5 times negative 2, positive times a negative makes negative 10. And then again, we just got to simplify this. So tidying it up, just being careful here because we've got negative 2, add 5 in the middle. Negative 2, add 5 is positive 3. So we end up with positive 3x in the middle. And again, keeping that negative 10 at the end, and that's there expanded. Okay, so this question says factorise fully. And that normally means because there's two factors that can come out. So let's have a look. We've got 12x squared and we've got 10x. Now straight away, they've both got an x in and they've both got a number. So let's just look at the numbers to start with. So numbers that go into 12 and 10, our only option there is 2. So we can definitely take a 2 out. But there's an x in both as well, so we can also take an x out. Okay, we're just having a look at what goes into both. 2 goes into both those numbers, and x goes into both the letter parts. So 2x on the outside, open the bracket. Now what do we multiply 2x by to get to 12x squared? Well, from 2 to 12 we have to times it by 6, and to make sure we get the x squared as well, we've also got to put an x in there. Again, just copy the sign, we finish with that piece. How do we get from 2x to 10x? Well, from 2 to 10 is 5, so times that by 5, but we don't want to put an x in with that piece because we don't want an x squared up here, just the 10x. So that's that one finished. There we go, 2x brackets 6x minus 5. Okay, so a different one. I've got a negative symbol in the middle, we've got negative 8x in the middle, and I've got plus 16 at the end. So same again, I'm just going to draw myself a blank double bracket and stick my x in the front of both of them. And then just think, okay, what numbers times to make 16? So I can have 1 and 16, I could have 2 and 8, and I could have 4 and 4. And then I just need to figure out which numbers are going to allow me to get this negative 8 in the middle. Now you might just be able to get to a point where you can actually spot this. I have got to be slightly careful in this one because it's a negative 8 and a positive 16. And thinking about the logic of numbers here, in order to multiply to get positive 16 at the end, this piece here, they're either going to both have to be positive or both have to be negative. But in order to get a negative 8 in the middle, it can't be the two positives, it's going to have to be the double negatives. So both my numbers here are going to be negative, and let's have a look why. So in order to get negative 8, I can't make that out of 1 and 16. I definitely can't make negative 8 out of 2 and 8, because one of them's already 8, so it's going to have to be 4 and 4. And the process of making negative 8, I could do minus 4, take away 4, so 2 negatives there, so negative 4, take away another negative 4, or take away another 4, would allow me to get -8 there. And again, you can always double check these, you can expand them. So if I expand it, I get x times x, which is x squared. I get x times -4, which is -4x. Same again on the bottom, -4x. And then -4 times -4, which gives you +16. And then again, just tidying up those middle pieces shows you why you get the -8 here, because we end up with x squared minus 8x plus 16 at the end. Okay, so you've always got that option there just to double check your answer. Okay, so looking at coordinates, it says write down the coordinates of point G. Now, point G is over here, so we just go reading the bottom, which is 4, and then whatever it aligns with going upwards, which is 3, so that would be 4, 3. Remember, with those coordinates, you read the x coordinate first, going across, and then however high up it goes. On to the next one, we're looking at h, so the coordinate of h goes -4 across, and then we're going down for this one, and it goes down to -1. So that coordinate would be -4, -1. You should be very careful not to get those two mixed up and writing them the wrong way round. For part C, it says find the coordinates of the midpoint. So to find the midpoint, there's a couple of different ways that you could do that. You could get your ruler and a pencil. You could join that up nice and straight using a ruler and a pencil like that, and then find the middle. And you could do that in two different ways. You could either do it by eye and try and spot the middle, or you're going to have to be absolutely perfect when you do that, or we could think about it as a bit of a pattern. Now, if you look at the actual points, if we look at a distance going across, it's 8 across to get from H over to G. That's a movement of 8, and we'd have to go 4 up to get to G, going upwards. So to find the midpoint, if we just do half of that, so if we go 4 across and 2 up from H, that's going to land perfectly on the midpoint. So you've got to remember those numbers. We're going to go 4 across, which gets us to here, and then go 2 up, which would get us to just here. So our midpoint, and I'll do this in a different colour, our midpoint is going to be on that coordinate right there. So that coordinate, if we write it down, is the coordinate, and that's 0 across, so it's 0, and 1 up, so 0, 1, and that'll be our midpoint. You just always want to check as well, is it 4 across, 2 up to get to there? Yep, so it's definitely the middle. So there we go, that's how you go about finding a midpoint. You just look at that little pattern and then halve it to see where the middle is. Okay, so on the grid, draw the graph of y equals 3x minus 2. Okay, this time it says for the values of x from -1 to 3. And again, that's what we actually have on the graph there. We have from -1 over here, going across from 0, 1, 2, and finishing at 3. So we can use all these x values to draw our little graph. And again, I'm just going to draw a little table for this. But again, thinking about this equation and what it actually means, it has a y-intercept there at the end of -2. So we know it's going to cross through this coordinate here. And it has a gradient of 3. Which in terms of just drawing a pattern, if I was to show you how I would actually draw this, if we go across one square, so that's 1 there, and then go up 3, again just being careful of the scale there, that's where our next coordinate's going to be right there. Okay, but we'll see that when we actually draw the graph. But you can actually just do this following the pattern. It's not going to help with the progression of this topic, but it does help make these ones nice and quick. You can just go across 1, up 3, cross 1, up 3, and you can just draw all these points in and join them all up. Okay, so this is what the graph is actually going to look like. And if we go across 1, down 3, there we are, there's our next one. So we could actually just draw this straight in, and it's a nice quick way of getting these drawn, but I'm going to get rid of that because it's not going to help us really with understanding this at the moment. So if I draw my x and y coordinates, x and y, and this one is 3x minus 2. So it says from -1 to 3, so -1, 0, 1, 2, 3, and again just sub in the points into the equation. So if I start with -1 again, let's just do this one to start with. So for -1, we have 3 lots of -1, and then take away 2. 3 lots of -1 is -3, take away 2 is -5. There we go, so -1 is all the way down here at -5, and we can put that into our little table. It's up to you if you want to draw the working out for all of them. I'm just going to follow this in my head now. So from 0, let's triple that, is 0. Take away 2 is -2. There we go. And again, we can start to look at the pattern here. And you'll notice it goes up by, again, this gradient, which is 3. It's going up in 3s. So if we just keep adding 3 each time, okay, because it's just a bit of a sequence here, a bit of a pattern, just plussing 3. And then again, add 3 for the next one. And just continue that little pattern, and that's fine. That's a nice quick way of getting these drawn. So add 3 to -2 is 1, add 3 again is 4, and add 3 again is 7. and then plotting all of these. So 0, minus 2, and there's that minus 2 that we knew we were going to get. 1 to 1, 2 to 4, and 3 to 7. There we go. Right, so this actually does say draw it from the x values from minus 1 to 3. So I am going to start from the one on minus 1. I'm going to connect it with a ruler and a pencil if you're doing it on paper up to the final point, but I'm not going to extend it this time because it just says to draw it between those two x values. Okay, so I don't need to extend it beyond the points. You don't need to label it, but it's, you know, if you want to label it, that's absolutely fine. You can just label it as y equals 3x minus 2. There you go, but don't feel that you have to do that. It's not, you know, unless you're explicitly asked to label it, you don't have to. Okay, so in this question we are given a line already drawn on a graph, and it says write down the equation of the line. Now we know already that what the equation of a line is going to look like. It's in this format, y equals mx plus c. Again, that's c being the y-intercept. Now we can see the y-intercept on the graph. It's over here, 5. So for starters, I can actually just draw that straight in. We can say c equals 5, and we can just put that in our line equation. So y equals mx plus 5. All we need to figure out is what the gradient is. Now if we have a look at this question, we've got to find some coordinates that we can actually see. So here's another coordinate that's on the line, 1, 3. Now if I want to find a gradient between these 2 points, all I have to do is draw a little right angled triangle in. So I can go across or down from this red point, but if I go across and then down, I'm just going to say how big the movement is there. So that's a movement of 1 there, and then that's going down 2, so I'm going to say that that's negative 2. Now the equation to get the gradient, there's 2 different ways that you can look at it. You can have a look at it, and it's just use this little triangle. It means the change in, so it's the change in the y coordinate over the change in the x coordinate, and it's sometimes referred to as rise over run. Okay, so you might know one of these two, but change in y over change in x, or rise over run. Now in this case, look, the change in the y coordinate is this movement here going down. It's minus 2. So that'll be on the top of my little fraction here, minus 2. And the run, or the change in x, is on the bottom there, is the 1 going across. So it's minus 2 over 1. And minus 2 divided by 1 is negative 2. Okay, so my gradient here is negative 2. So it's obviously sloping downwards, which is why it's got a negative gradient. But that's what our gradient actually is for this question here. So all I've got to do is put negative 2 in place of m, and we get y equals minus 2x plus 5. Obviously thinking about that last question that we looked at, you could actually write that as 5 minus 2x, but you can write it in either way. It's absolutely fine to do so. Just a little side note, you can actually do these triangles as big as you want. If I picked some different coordinates, let's have a look, that one there and this one here for example, and if I was to go down instead and make a big triangle like this, let's have a look. My run there is 4, and my rise goes from 7 down to negative 1, which is a movement of minus 8. And if I did rise over run for this one, or the change in y over change in x, it would be minus 8 over 4, and minus 8 divided by 4 is minus 2. So you can do this however you like, okay, because it's a straight line, it doesn't actually matter where you do the gradient from. It's just you just need to draw it in, just read those numbers very, very carefully so you can get the correct gradient there. Okay, so looking at drawing some shapes, and there's lots of different options for ways that you could draw these, but this is on the grid, draw a parallelogram. Now when we're drawing a parallelogram, we do need all those pairs of sides to be parallel. So we're going to draw one pair of parallel sides, and they have to be just off. Now if I was to just draw it straight underneath like this, that would be a rectangle. So with a parallelogram, it's almost a little bit slanted, so I just need to draw the same size line, so 5 squares across, but not perfectly underneath it. So there we go, 1, 2, 3, 4, 5, and then those lines are parallel, and then the connecting lines as well, this one and this one, will also be parallel, and you can put parallel symbols on there if you want, although as long as the parallelogram is drawn perfectly, you don't actually have to add those on. But if you have a look, it's just very important that when you join these up, this point and this point here have the same distance pattern between them. Okay, obviously I'm going to get rid of those because then it wouldn't be a parallelogram anymore, but you can see the pattern that you have to do in order to draw one perfectly. Now for the next one, it says to draw a kite, and to draw a kite we need to create, let's just have a think how I draw it. And we know what a kite looks like. It looks something like this, where these two sides are the same length and these two sides here are the same length. So obviously I could draw this any size, so I'm going to draw the top bits to start with. I'm just going to go from there to there, and then the same pattern the other way around. So there is that line of reflection going down the middle that we have in a kite, and I'm going to do all the way down to the bottom of the grid. So we'll go down to here, down to there, and as well you could add these lines on if you want for a kite, although again, as long as it's drawn perfectly, you don't have to add those on. So there we go, that is a parallelogram and a kite. A kite should have those two sides of equal length at the top, two sides of equal length at the bottom, and that perfect reflection line down the bottom, so it's the same either side, and your parallelogram there on the left. So there we go, there's a couple of different shapes that you could have to draw. Okay, so this question says to draw and shade a sector of the circle. So a sector makes a nice sort of like pizza slice shape. So we draw from the centre out to the circumference there, and we could shade that in, and that would be our minor sector. You could actually shade in the outside of that, and that'd just be a major sector as well. It doesn't dictate which one we need to shade, just says to draw a sector. So there we go, there is a sector. And for the next one, it says to draw a segment. Now a segment is created by drawing in a chord. So we're going to draw a chord in, and it makes this sector here, or this segment, sorry. And there we go, that is a segment. So there's a couple of other bits that we could draw on here. Obviously the sector here is made using a radius. So you actually drew a radius in there to create that. And the segment was made by drawing in a chord. So there's a couple of other bits of circles as well. But you could also be asked to draw a tangent, which is a line that just touches once on the outside and carries on going. And you could also be asked to draw in a diameter as well. And then a diameter is just a chord that goes through the centre. Hopefully you already recognise what a diameter looks like. But there we go, there's a few different parts of circles that we could be asked to draw. Let's have a look at our next question. Okay, so this question says work out the length of BC. Let's just identify that there. So the length BC is this length across here. And it says give your answer to correct to 3 significant figures. Now straight away it doesn't actually stand out that you definitely need to use Pythagoras for this, but we are working out lengths, and Pythagoras is one of the skills we have to work out lengths in different shapes. Obviously only when it comes to right angled triangles, but different shapes, if we can find a right angled triangle somewhere, we can apply Pythagoras to help us work it out. And in this type of question, look, if I chop from the D down to the base, that creates a right angled triangle here on the right. And we have a rectangle on the left. Now because it's a rectangle on the left, we can say that the 2.1 there is the same as the 2.1 down here. And that's in metres, and the 1.9 there is the same as the 1.9 over here. Now that means that we've got enough lengths in this right angled triangle now. We've got the 3.2 and the 1.9 to work out the lengths down the bottom here, which I'll put a little X next to. And then once we've got that, we can combine it with the 2.1. So looking at that right angled triangle we've got the hypotenuse look opposite our right angle. So we're going to do square, square, and then minus, and then root. So 3.2 squared, take away 1.9 squared. We'll work that out and then root the answer. So on the calculator, 3.2 squared, take away 1.9 squared, and that equals 6.63. There we go, 6.63. So square rooting that, so 6.63, the square root of that, and that equals, let's have a look, 2.5748. 2.5748 and a few more decimals. Now again, it says it wants our answer correct to 3 significant figures. Obviously just make sure you read that. So if we round this to 3 significant figures, we get 2.57. There we go. And this is in metres this time, so 2.57 metres, and I can label that down here, 2.57 metres. Now I can work out the full length of BC there, because we've got the 2.1 and the 2.57, and if we add those together, 2.1 plus 2.57 comes out as 4.67. So let's just write the working out for that down up here. 2.1 add 2.57. I should probably tidy that up with a 0, and that comes out as 7, 6 and 4. So 4.67 metres, and there is our final answer for that question. Let's have a look at one other kind of question similar to this one. Okay, so this question says work out the length of AC and give your answer correct to 3 significant figures. Now if we have a look, just to start off with, if I was to connect A to C, it would form this length right here. And that obviously just starts to throw things up a little bit. So I'm actually going to take a slightly different approach to this to start with, because if you have a look, the right angled triangle that we've created here, we've got the 9, we've not got the hypotenuse, and we've not got BC. So because I've only got one missing length in that triangle, it's pretty useless for me to have a look at it at the moment. So there must be another length we can find first. So if I come back to this and let's have a look. Looking at what we've got at the moment, if I try and find a right angled triangle somewhere, I can do that this time by chopping across. And if we chop across there, we might be able to work out this length down here. Obviously that was the base of the big right angle triangle we've just drawn. Let's have a look if we can do. Now we've got a rectangle on the bottom. We don't know the top and the bottom, but we do know that the 3 over here, which must mean this is 3 over here. And the full length of AB, this length here, it says is 9. So if that part that I've just drawn in is 3, this top bit here must be 6. And that now means that in this right angle triangle, we've got 2 of the missing lengths, and we can work out that dotted line there, which is going to be the same as x down the bottom. And I can do that again using Pythagoras. We've got the hypotenuse there, which is 10. So we can do 10 squared, take away 6 squared, and 10 squared take away 6 squared is 64, I believe. Let's just have a check. That's 100 take away 36, which yes is 64. Okay, so that's quite a nice one, because we can square root that without a calculator. And the square root of 64 is 8 centimetres, there we go. So this length here, and let's do that in a different colour, is now 8 centimetres. That is not a C, that's a backwards C. I think I was going to write 8x there, so 8 centimetres. And that is the same as the x down the bottom, 8 centimetres as well. So now we've got that. And again, I've had to do a bit of drawing over the diagram here, but if we get rid of this now, and we have a look at what we've now got the base of that right angled triangle that I drew in initially. And if we connect up A to C, look, and I've not done that very well there, it would be handy if I could do this with a ruler, but A to C, there we go, has now formed this big right angled triangle. And if I just highlight that, we've got a big right angled triangle there, which we now have 2 of the missing lengths for. We've got the 9 on the side, which was the full length that we had initially, and we've now got the 8 centimetres down the bottom there, which we can now use to work out the length of that hypotenuse, which is the length AC. So to work that out, just a nice bit of Pythagoras here. Look, we're trying to find the longest side. So we've got 9 squared plus 8 squared, and 9 squared plus 8 squared, and this is a calculator question because it says 3 significant figures. It comes out as 145, and we need to square root 145, and the square root of 145 is 12.0415. There we go, 12.0415 and a few more decimals. Now to finish this question off, we've just got to round it. 3 significant figures, so 1, 2 and 0 is my third, and that 4 isn't enough to round it up, so it goes to 12 point, and here's a good little tip here, look, we have to keep the 0 in there. That is our third significant figure. So although we wouldn't normally write 12 as 12.0, it's asked for 3 significant figures, so we do have to keep the 0 in there, and that is centimetres, and there we go, and there's our final answer, 12 centimetres. Okay, so it's just thinking about a different way of using Pythagoras. That one there was a little bit trickier because we had to go in 2 steps and work out a different line before looking at AC, but there's just something to be thinking about. Okay, so this says Dave is a cleaner. It says the table shows some information about the time it will take him to clean each of the 4 rooms in a house. He wants to clean all 4 rooms in one day, and he's going to have breaks for a total of 75 minutes. He's going to start cleaning at 9 AM. Will he be finished by 4? And you must show you're working. There's a couple of different ways that you could do this. You could start at 9, and you could start adding all of these times onto 9 and figuring out the time as you go along. Or of course what we could do is we could work out how many hours there are between 4 PM and 9 AM, and then just add them all up and see if it's more or less than that number. I think that's probably the quickest way for this question, so that's how I'm going to do it. But of course you could take another method. So from 9 AM to 4 PM, that is, well, it's 3 hours until midday and another 4 hours. So in total, that's going to be 7 hours. So if we write that down, that is going to be 7 hours between those two. So we just need to add all of these up and see if that's going to be more or less than 7 hours. Now to start with, we don't want to forget about this 75 minutes. So I might just add that over to here. And while I'm doing that, I'm just going to write it as 1 hour and 15 minutes. There are 60 minutes in an hour, so I'm going to write 1 hour, 15 minutes. and that's the break. So I'm just going to put the break down there. Right, so we need to add these all together. So let's go step by step. We've got 2 hours. I'm going to add all the hours up. We've got another 1 hour. So that's 3 hours. We've got 1.5. To be fair, we could add that in one go. So let's go for 4.5 hours, adding all of those. We've got 5.5 hours when we add this hour here. We could add then the 45 minutes, and the 15 is another hour. So you might want to just start writing these down so that you don't forget them as you go. So that we had the 2 hours plus the 1, which got us to 3 hours. Then we had the 1.5 hours, so 4.5. The other hour, so 5.5. We've now got the 45 minutes and the 15 minutes, which is another hour. So that's 6.5 hours. We're very close to that 7 hours. And the last bit we've got to add is the 40 minutes. So if we add 40 minutes on, we're at 6.5, which is 6 hours and 30 minutes. So if we add 40 minutes to that, that's going to go to 7 hours and 10 minutes at the end. So that's gone just over our 7-hour limit. So in terms of this, will he finish by cleaning by 4 p.m? No, because he will finish at 4:10. There we go. No, he will finish at 4:10 p.m. Okay, so there's our final answer. Now, obviously, I chose a particular way of adding those numbers together. You can do any particular way that you want here, but as long as you're getting 10 past 4, then your method's obviously absolutely fine. But 10 past 4 is the answer there, so no, he will not finish at 4 p.m. It says Ben is going to cover the floor with wooden floorboards, and it gives us a diagram of the floor. It says 1 pack of floorboards will cover 2.25 metres squared. How many packs of floorboards does Ben need? So the first thing that we actually want to work out here is the area of this compound shape. And there are 2 different ways of doing that. So as you can see, it's this kind of L shape at the moment, and it's made up of 2 rectangles. So we have to split this up into individual rectangles so we can work out their areas. So you have 2 ways of going about that. You could go across and you could split it up into rectangles that way, or you could go upwards and you could split it into 2 rectangles that way. Of course, you could do both and you could split it into 3 rectangles, but that's probably going to make a little bit more work for yourself. So let's just go with splitting it across and working out the area of these 2. So for the bottom rectangle there, you have a length and a width of 3 and 2. So that's going to give us an area of 6 metres squared. Again, just doing 2 times 3. For the top one, you have a length and a width of 4.5 and 2. So if we do 2 times 4.5, that is going to give us an area there of 9 metres squared. So overall, we can work out the actual total area. And 9 and 6 is going to give us a total area of 15 metres squared. Again, just showing you're working out and how you've added them together. So the area of the floor is 15 metres squared, and it said in the question that 1 pack of floorboards will cover 2.25 metres squared. So in order to work out how many packs that we need to buy, we have to do 15 and divide it by the 2.25. So if you have a calculator, you can just type in 15 divided by 2.25, but if not, you are going to have to just count up in 2.25s. So what you could do is just start making a list. You could do 2.25 plus another 2.25, which would be 4.5, and you could build your way up. But if we do this on a calculator while we're practicing, you'll see that you get the answer 6.6 recurring. Now obviously, we can't go into a shop and buy 6.6 recurring packs. So when it comes to a question like this, we have to actually round that up. The reason that we have to round it up is obviously if we were to buy 6 packs, then we wouldn't have enough. And if we were doing this in real life, we would have to just buy more packs than needed, and we would have some spare left over at the end. So when we get this scenario, we will round that up and we would say 7 packs, and that would be the final answer for this question. Obviously, the question could go a little bit further. It could tell you the cost of each pack and potentially ask you to work out the total cost of buying them. So you have to remember to round it up, because in real life, again, we would have to buy the additional pack there, which would give us some left over, but that would be absolutely fine. So this question here. Now this is an interesting one again, because it's not necessarily a compound shape. Now before we read the question, you can see that what we have on the screen is a trapezium, but a trapezium could be viewed as a compound shape if we split it up into a rectangle and a triangle. Now hopefully we're not going to have to use that for this question, but another one of these functional type questions here where we are looking at grass seed instead of something like varnish or floorboards. So this question here says Jane wants to cover her lawn with grass seeds. 1 bag of seed will cover 20 metres squared, and each bag of seed costs £4.99. Work out the least cost of putting grass on Jane's garden. Okay, so for this question we're going to have to work out the area of this shape. Now thankfully we do have the height of this shape, so we could use our area of a trapezium formula. And we know with the area of a trapezium that you do the parallel sides added together divided by 2 and then multiply it by the height. And remembering that formula, which we looked at in a previous video, which I will link here for you, is half a plus b and then multiplied by the height. So if we plug those values in, we have 12 plus 18, which is equal to 30. We would divide that by 2, which is equal to 15, and then we would multiply it by the height. So we need to do 15 times 9, and when you work out 15 times 9, you get a final answer of 135. And this again is in metres, so that is 135 metres squared. And again, you can take your time working that out. So now we have the area, we need to work out how many bags of seed she needs. Now it again said that one bag of seed covers 20 metres squared. So we would need to do 135 and divide that by 20. Now again, if you do that on the calculator, or you could just count up in 20s, but if we do 135 divided by 20, we actually get the answer 6.75. So we know that we have to get 6.75 bags. But again, it comes down to that issue where if we have a decimal amount, then we're going to have to round that up, and we're instead going to buy 7 bags of seed. Okay, so now we know how many bags that we need, we can multiply that by the £4.99. It says each bag of seed costs £4.99, so we just need to work that out. So I'd do 7 times £4.99, and again, if you don't have a calculator for this particular question, you could do 7 times 5 and then take away the 7 extra pennies there. 7 times 5 would be 35, take away the 7 pence, would leave you with £34.93. Again, if you don't like that method, then you could hop the decimal out, and you could do 7 times 499, and then obviously hop the decimal back in 2 jumps. So both answers, both methods there would give you this £34.93, but again, if you had a calculator for this, that would be nice and easy because you would just type it in. So the least cost here that it's going to cost is £34.93, and that comes from buying the 7 bags. Obviously we're going to have a little bit left over there, but it doesn't say that the bags can be sold in particular portions. You do have to buy the entire bag for £4.99 and just have some left over. So we're going to start with this question here, and it says in a bag there are only red, blue and white counters, and a counter is taken at random from the bag and the table shows the probability of each colour. Obviously though, we can see we are missing a colour, we're missing the probability of white just here, and we'll have a look at that in just a sec. It then says James is going to take a counter, replace it and take another, and he does this 50 times. Estimate how many times he'll take a white counter. Now obviously we don't know the probability of white, but we can actually work that out. Now when I look at these probabilities in a table, I like to think of these decimals here as percentages in disguise. So this one here, 0.5, is 50%. Okay, and we can look at that as a percentage instead of a decimal. Blue we've got there is 0.3, and that's 30%. There we go. And that is our second percentage. Now, all of these probabilities have to add up to 100%. So at the moment, we've got 50% and 30%, and that adds up to a total of 80% at the moment. There we go. So we're missing 20%. So that missing 20% is our decimal for white, okay? And obviously we're writing this as decimals, so if we want to have a look at it in terms of the decimals, we could think of it as 0.5, add 0.3, that gives us 0.8. If we look at it in terms of the decimals, there we go. So to make that equal 1, we are missing out on 0.2. So the probability of white is 0.2, or logically, if we think about it, that's 20%. Now the reason I think about it in terms of a percentage is because it's going to help us further down the line with some of these questions, and it's going to help us with this second part of this question. So it says he takes a white counter 50 times. So if he takes the white counter 50 times, we would expect him to take a white 20% of the time. Sorry, he doesn't take a white counter 50 times, but if he takes a counter 50 times, we would expect it to be white 20% of the time. So really all this question is asking us is to work out 20% of 50. Okay, so all we've got to do is pick out that little percentage question. So really we just need to find 20% of 50, and we can do that quite nice and easily. Always find 10% to start with, so 10% of 50 equals 5, and 20% is double that, so 20% is going to equal 10 times. There we go, and there's our final answer, 10. Now, just another note on this, it does say that word estimate. Now, normally the word estimate does mean to round, doesn't it? It means to round to one significant figure and make a little bit of a guesswork. Now, in this scenario here, the word estimate is just because we are using the probabilities in order to do so. Okay, it's like when we flip a coin, it's a 50-50 chance that we'll get a head or a tail, but if we flip it twice, we're not necessarily going to actually get a head and a tail. We could get two tails, okay? So that's what the word estimate means in this scenario. It just means the fact that we are using the probability in order to make our best guess on how many counters or whatever the question's about we're actually going to get. So there we go, that's this question sorted. Find the missing decimal in the table. Obviously you can think about that in terms of a percentage or in terms of a decimal. They've all got to add up to 1, or they've got to add up to 100%, depending on which way you want to look at it. And then you just need to have a look at the second part of the question, have a think about what percentage of what it's actually asking. So in this circumstance here, it said 50 times, and for the amount of white counters, we identified that the white counters was 20% or 0.2, and therefore we could get 20% of 50 there. Now, if you have a calculator, there is a nice quick way of doing this. I don't think it necessarily helps for the progression of this topic, but there is a quick way of doing this as well. You could just do 50 and multiply it by 0.2. And that just on your calculator basically is just a calculator way of saying work out 20%, okay? So it is the same process, but you'll get the same answer there. So you can just do a little bit of a shortcut if you want to take a nice quick approach using a calculator. Now, when it comes to independent events, we're going to talk about it throughout the video, but an independent event is just two events where the second event is not affected by the first event. And we'll have a look at why it's not affected in these types of different questions, but it's just, that's all that it means there. It just means that the one event that we're looking at is not going to be affected by the other. So let's have a look at this question. Now, in a lot of these questions, you'll normally actually be given a tree, but in none of the ones that I'm going to have a look at, I'm actually going to give the tree. We're just going to draw them all ourselves, because obviously if you're not given the tree, it's important that you're able to do that anyway. And if you are, then that's easier for you. So we're just going to have a look at these slightly harder questions here. So James has a bag of counters, and in the bag there are 4 red and 5 blue, and James takes at random a counter from the bag and notes its colour. He then puts the counter back in the bag, and that's an important bit we're going to discuss there, and takes at random a second counter, and we're going to work out the probability that James takes 2 different coloured counters. So that line there where it says he puts the counter back in the bag, that there is what determines that this is an independent event, because after we take the first counter, if we put one back in the bag, the second time we're just taking a counter from exactly the same bag of counters. So it doesn't actually matter whether we take a red or a blue. So let's have a look at constructing this via a tree. So if we draw a little tree here, we're going to draw 2 branches that represent red and blue. Okay, and that is going to be representing our first pick of the counters there. I'm going to label this part of the tree, so that's the first time we take a counter. Now let's write the probabilities in. So looking over there, we've got 4 red and 5 blue. So in total there we've got 9 counters. So you can do that working out to the side if you want. 4 plus 5 equals 9. So if we're going to write the probabilities here, I'm going to write them as fractions, just keep it nice and easy. Obviously you can write it as decimals if you like, but I think in the case of this question it's probably easier for us to write it as a fraction. So for red, it's 4 reds out of 9. So the probability of getting a red is 4 out of 9. And then we've got blue, and that is 5 out of 9. There we go. And just thinking about these fractions here, obviously if you were given the tree and you were you didn't have the information up there and it said that the red was 4/9, you'd have to actually work out the blue there, and obviously the numerators have to add up to whatever that denominator is. If it's 4 out of 9, that tells you there's 9 counters, 4 of them being red, and therefore 5 of them have to be blue in order to make 9 out of the 4 and the 5. So just thinking about that, if you weren't given the the information in the question, you'd have to actually do that yourself on the tree. Now obviously what we have the little scenario here, and I always like to think of it as a bit of a journey. So if we imagine a little person standing over here at the start, not the best drawing there, but we could either go on a little journey. Now we could take a red out of the bag, in which case our little person would end up here, and then we'd have our second counter. So at this point we can construct the second part of our tree, and I'm going to run out of a little bit of space here, and this is going to represent the second pick. Now on this second pick here, look at this part of the journey, we've taken a red counter, and now we're going to take another one, and again that can be red or blue. And because the counter's gone back in the bag, again it's going to be 4/9, and it's going to be 5/9 again for blue. And that is that one part of the journey. But of course we might not have taken a red out, so if we get rid of our little person here, and let's imagine that actually instead we've taken out a blue, and we've gone down this part of the journey here, we've taken out a blue counter. So here we are, we've taken out a blue. Now again we're going to take a second counter, okay, and that again can be red or blue, so we'll label that up, red or blue. And again, the probabilities are just going to be exactly the same. It doesn't matter whether I took a red or whether I took a blue. It's still 4/9 and 5/9 as that counter has been put back in the bag. So we've constructed our tree. And let's have a look. Let's just get rid of all of this. We now just need to work out this probability. And now the question says, work out the probability that James takes 2 different coloured counters. And there are 2 ways that I can actually do that. So to get different colours, I could, and I'm just going to squiggle along the lines, and this is how I do it. I go up the red, and then I'd have to take a blue. And the 2 probabilities that you go through on this journey are really important. So we went through 4/9 when we took the red, and we finished on the 5/9. So to work out the probability of that route happening, all we do is we multiply those 2 fractions together, and all you've got to remember is you times when you go across the tree. So if we times them together, we've got 4/9, and we're going to times that by 5/9, and that's really nice and easy. Not to forget, when you're multiplying fractions, you multiply the top numbers. So 4 times 5 is 20, and 9 times 9 is 81. So the probability of getting a red and then a blue is 20 out of 81. Now, not that that one can simplify, but you do not need to simplify fractions when it comes to probability. And the reason being is that that probability there, 20 out of 81, tells us something quite important. It tells us that there are 20 different ways of this happening out of a possible 81 different ways of picking all these counters. That can seem a little bit hard to understand sometimes, but if we labelled the red ones 1 to 4 and the blue ones, let's say 1 to 5, there are 20 different ways of taking a red than a blue. I could take red counter number 1 and then blue counter number 1. Or I could take red counter number 1 and then blue counter number 2, etc, etc. Obviously they're all still red and blue, but if they had different numbers on, and we think of them as, you know, all different counters, then there are 20 different ways of doing that. Now what we're going to have a look at now is the other way of getting 2 different counters, because I could take, instead of a red then a blue, and let's think, I'm just going to do a different colour here, I could take a blue and then I could take a red. And that would also give me different colour counters. And again, that goes through these 2 different fractions, so 5/9 and 4/9. And if we times them together, you'll probably notice here that actually we're going to get the same answer, because it's the same 2 fractions in reverse. And 4/9 times 5/9, again on the top we get 20, and again on the bottom we get 81. But that there is taking a blue then a red. Okay, and there are 20 ways of doing that as well. So there are 20 ways of getting a red then a blue, and 20 ways of getting a blue then a red. So the total probability there, in order to get our final answer, we just need to add these 2 together to combine them to get the total probability there. So 20 plus 20 on the top gives us 40 out of the possible 81 ways. Remembering you don't add the denominators together there when adding fractions, and that would give us our final answer, 40 out of 81. Okay, so a few different things to be thinking about there. One was constructing the tree, thinking about obviously our first pick and our second pick, and then the next one was obviously multiplying across the tree, and any different combinations that we have at the end, we just add them together and combine them together. Of course, you might get a nice easy question here. It might just say, what's the probability of taking 2 reds? In which case you only need to do the one journey. Have a look at the tree there, that goes through the 4/9 and the 4/9. So you just times them together and that'll be your answer. But if there are multiple answers, you just need to think about adding them together at the end. So let's have a look at a slightly different question. Okay, so this question here says Mary has 2 bags of counters. In bag A there are 3 red and 2 blue, and in bag B there are 4 red and 3 blue. It says Mary takes at random a counter from bag A and notes its colour. She then takes at random a counter from bag B. Work out the probability that Mary takes the same coloured counters. Now again, this is an independent event because they're 2 different bags. It doesn't matter whether we take a red out of bag A, that's not going to affect the probability in bag B because that's a completely separate bag. So again, we can construct a tree for this. Now it starts talking about bag A, so I'm going to start with my tree being about bag A, and I'm going to label that up here, bag A. There we go. And again, it's red or blue. Now I've decided to stick with red and blue counters for all of these questions here, but there could be any sort of different combination of counters or pens or anything, or marbles it sometimes goes on about. We just need to make sure we read the story and construct our tree. So for red, there are 3 reds and there are 2 blues. That's out of 5 in total. So for red, it's 3 out of 5. And for blue, again, it's 2 out of 5. Remembering, obviously, that those numerators have to add up to 5 in this scenario if you weren't given the information. So that's our pick out of bag A. And then we've got to have a look at bag B. So again, I'm going to label the second branches of the tree over here bag B. But again, we have 2 different scenarios. Now, we could take a red, in which case we're looking at this part of the tree. And again, it's a red or a blue. And in that second piece of information there, let's highlight that. There are 4 reds and 3 blues. So there'd be 4 out of 4 plus 3 is 7, so 4 out of 7 this time, and it'd be 3 out of 7 for the blue. Of course, we could have taken out a blue out to start with, so we could be on this part of the journey, and again, there would be a red or a blue, but nothing's going to change down there. It doesn't matter whether we take a red or a blue out. Red and blue are going to stay the same, so it's still going to be 4 out of 7 and 3 out of 7. And there we go, that's our tree constructed. And again, just thinking about obviously those second little sets of branches there, both are the same top and bottom, as it's an independent event, and it doesn't say anything changes. You know, it might say if so-and-so took a red in bag A, that the probability changes in bag B. If it doesn't state anything though, we always just assume that it's always going to be the same there, as it doesn't say anything's going to change. So it says here, work out the probability that Mary takes the same coloured counters. So again, just thinking about the logic here, like before, we had red, blue and blue, red for different coloured counters. This time it's the same coloured counters, and there are two ways of doing that. We could get a red going through the 3/5 there, and another red going through the 4/7. So that is our two fractions that we're going to have to multiply this time. So if we do those, we get 3/5 multiplied by 4/7, and again, times in the top gives us 12, and times in the bottom gives us 35. So there are 12 out of 35 ways of getting two reds. And then obviously thinking about the fact of the same colours, we could have two blues. So if I go through blue, 2/5, and through the other blue, 3/7, that's going to give us our second probability there using those two fractions. So if we write those down, we have 2/5 multiplied by 3/7, and that gives us 6 on the top and 35 on the bottom. So telling us there's 6 out of 35 potential ways of getting two blues. And again, finishing this question off, we've got two probabilities that we need to add together. So I'm just going to write down the sum this time. We've got 12 out of 35, and we need to add to that 6 over 35, and 12 plus 6 is 18, and that is out of 35, again remembering not to add the denominators together there. So 18 out of 35 is going to be our final answer for this question, as our probability of getting the same colours. Remembering again though, you could get a nice easy one. It could say what's the probability of two blues, in which case we'd have just gone along that purple route and got 6 out of 35. Okay, so just thinking about obviously the slightly harder style questions here rather than just one straight route. Okay, so if you're able to do these, you're able to do most of those questions there. The great thing about a pie chart is that all of the numbers in the question that we're going to have a look at need to add up to 360. We know that around a point in a circle all the angles add up to 360. So that in order for our pie chart to work, it has to add up to that number. So if we look at our question, we're going to find the numbers that are associated with our question. We're going to get the numbers to add up to 360, and then we're going to draw it using our protractor. So we're going to run through all of that. I've got a question for you to practice and one final question for us to have a look at, but it's going to be a relatively quick video looking at drawing pie charts. So this question here says the table gives information about the languages studied by a group of Year 11 students, and it says that 30 study French, 37 study German and 53 study Spanish, and it says draw an accurate pie chart for this information. So the first thing we want to do is add up all these numbers. So if we add up 30, 37 and 53, let's have a look, that adds up to 120. And I always just write that down over here somewhere near the table, just so I know what the total is, and the total there is 120. So in order to get this to 360, either you just have to think about that in your head, what you multiply 120 by to get to 360, or we could just do 360 and divide that by the total there, which is 120. So 360 divided by 120 is 3, meaning that we're going to have to multiply all of these by 3 to get the angle in each portion of the pie chart. So if we multiply them all by 3, and we'll just write times 3 next to them all, there we go, times 3 times 3 times 3, that would mean that 30 would become 90 degrees, and these are our angles now. We would have 37 times 3, which would be 111, so that would be 111 degrees, which is a bit of an awkward one to draw, and 53 times 3 would be 159, so that is 159 degrees. Now that is the main bit of our working out now. We know all of the angles that we need to draw, we just actually need to draw them on correctly. So when you've got your pie chart drawn like this, if it's given to you, if not, you're going to have to use a compass just to draw a circle. And if you're making notes on this, I would definitely do that. Just get your compass, draw a nice circle, just make sure that you know where the centre of that circle is, so that you can draw this nice straight line going up so you have a place to start from. So let's start with drawing on this French one, which is 90 degrees. And we can put them all in at the same time, but let's do the first one. So get your protractor, pull it over the top of the pie chart, make sure that little crosshair in the middle is right on the centre, And there we go, I'll just do that really nice and carefully. And then you also want to rotate your protractor so that the guideline where it starts at 0 is lined up with the line that you're starting from, which is the one that's vertical. So there we go, that's nicely lined up. So I want to mark on 90 degrees. So I'm just going to mark the 90 degrees over there. There we go, pull your protractor out the way. And then with a ruler and a pencil, from that central point, draw a nice line over to that. And you can obviously do it a little bit shorter, just to the edge of the pie chart. And there we go, that's your 90-degree angle. Now you can move on to the next one. But before you do, what I tend to do is I normally tend to label that section. So I'm just going to put French in there. So I'll put French in, and I'll also put the degrees in there, 90 degrees. You could also put the 30 in there as well, but just to keep it a little bit simpler on the screen, it's going to leave it as French with the 90 degrees. Okay, so putting your protractor back onto the centre. Now we just want to rotate the protractor round so that the 0 is lined up with our new line, so we can carry on from that point. And again, I'm using the outside numbers. And now we need to do 111 degrees. So past the 90, 110, 111 is just past that, and you're going to have to just get it as accurate as you can. There we go, there's 111 for me. Again, just pull that protractor out of the way, and we can draw in a nice straight line again from the centre. So from the centre, ruler and a pencil, join it up. I'm just going to shorten it a little bit. There we go. You can do that a little bit easier when it's not on a screen, but yeah, there we go. Using your ruler and a pencil, I'm just going to label that. So that would be German, and that was 111 degrees. There we go. And the last part of the pie chart here, which, as we only have one left, is Spanish. So we'll label that as Spanish, and that is 159 degrees. A good bit of practice here that you should do is you should stick your protractor on, just measure that final angle there. So I'm going to flip it around the other way, measure to see if that's 159. Might be a little difficult for you to see on the screen there, but that comes out as around 159 for me. So I'm happy with that. It's an accurate pie chart. All of the angles match up to what I wanted them to. And there we go, there's your pie chart. Okay, so that's how you go about drawing it. That's how you get the angles. Remember, they've got to add up to 360. So that bit of working out there where I added up the total and did 360 divided by that total allowed me to see what I needed to multiply all those numbers by so that they all added up. And another good bit of practice that you could do is take those three numbers and just add them up, and you can actually see 159, 111 and 90 do all add up to 360. So we've definitely got it right. Okay, so there we go, that's how you're going to do it. Okay, so looking at some mean and range. Now part A here says work out the range of the numbers on these cards. So we've got all the cards at the top. To work out the range, we want to do the biggest take away the smallest. So the biggest number on the cards right there is 8. The smallest number on the cards is 1. So we'll just write that working out down. 8 take away 1, which is 7. So the range on the cards is 7. The next one asks us to work out the mean. So to work out the mean, we need to add them all together. So if we add all of these up, 3 plus 1 is 4, 5, 6, 7, 8, 9, 15, 23, 32. So they all add up to 32. So to do the mean, we do 32 the total, divide by how many cards there are. There are 1, 2, 3, 4, 5, 6, 7, 8. So 32 divided by 8, and that is equal to 4. So our mean would be 4. So there we go, that's how you work out the range, biggest take away smallest, and to work out the mean, get the total, divide by how many there are. And there we go, there are our averages. So it says here there are 10 boys and 20 girls in a class, and the class has a test. It says the mean mark for all the class is 60 and the mean mark for the girls is 54. Work out the mean for the boys. So when it comes to a question like this, obviously we know, or hopefully we know, that when we're normally working out a mean, we get the total, we divide by how many people there are or how many things there are, and we get our mean. Okay, so we do the total and we divide by the amount, okay, for whatever it is. There we are, on its most basic sense there with the mean. You do the total divided by the amount. Well, in this question here, obviously it doesn't actually give us the total. It tells us what the mean is, it tells us the amount, it tells us that there are 10 boys and 20 girls, but it doesn't actually tell us the total. So what we're going to do is we're going to go backwards to work out some of these totals, okay? So we're going to think about this in reverse, all right? And that is how you get the mean there, the total divided by the amount. Okay, so if we link some of these things up, then it says that there are 10 boys. It doesn't give us the mean for the boys, so that's no good so far. So that first piece of information that we are actually given in terms of the mean, it says the mean mark for the whole class is 60. Well, if we were going to work out the mean for the whole class, we'd get their total. Let's call that x. we divide it by the amount, and in this case the whole class, well, there's 10 boys and 20 girls, so we would divide it by 30, and it would give us this mean here, which it says is 60. So in other words, we're looking for a number that divides by 30 that gives us the answer 60, and we can just do that in reverse. We can just do 60 times 30. So actually all we're going to do in these questions is we're going to link the mean that we're given with the amount that is appropriate for that mean. So I'm going to get rid of this little bit of algebra that I've drawn here, but obviously you could think of it in terms of an equation, but this is the sort of concept that we're going to run throughout this question, and hopefully once you actually get your head around this and why we multiply instead of divide, obviously we are doing a reverse. This question obviously becomes a lot easier then. Okay, so obviously thinking about this topic's actual name, it's called a reverse mean. Normally when you work out the mean you do a divide, and obviously then the opposite or the reverse of dividing is multiplying, and in these questions we're going to be multiplying rather than dividing to go backwards. So let me get rid of that. So let's have a look. So obviously we've been given that the mean for the whole class is 60, and we've just established that there's 30 students or 30 people in the whole class. So we're going to do 60 times by those 30 students, and that's going to tell us their total. So 6 times 3 is 18, add on the 2 noughts, that's 1,800, and that is the total for the whole class. And it's usually worth just labelling these, particularly if you haven't quite got your head around it. Let's just label that total for class. There we go. Right, so the next bit of information then, we've also been told that the mean mark for the girls is 54. Now, in terms of the question, look, there are 20 girls. So if there's 20 girls and their mean is 54, we'll take their mean, 54, times it back by that 20 to find out what their total was. So 54 times 20, there we go, and that gives us 1,080. And there we go, there is the total for the girls. And let's just label that again. Total for girls. Right, so just thinking logically about the information that we've got here, we've got a class of boys and girls. It says the total for the class is 1,800, the total for the girls is 1,080. So logically we can work out now the total for the boys, we can subtract those away from each other. So 1,800, take away 1,080, and let's write that down. There we go, take away 1,080, leaves us with 720. There we go, and that's the total for the boys. Let's label that up, total for boys. And now we can go about answering the question, because now we know the total for the boys, we can actually think about working out their mean, and that's what the question wanted. It said work out the mean for the boys. So we've got the total for the boys is 720, and in total up here we were given in the question, let's highlight it in the same colour, there are 10 boys. So to work out the mean, just like normal, we would just finish this off by saying the total for the boys is 720. I'm going to divide that by how many boys there are, which is 10, and that gives us a mean of 72. There we go, and there's our final answer. And just thinking about what we did there, just working backwards through the question, multiplying the means by the amount to get the totals, and then using a bit of logic there to find out therefore what the total for the boys must have been, and then just working out the mean as normal. Okay, well done for sticking with me. That was absolutely loads of maths that we've just gone through, but hopefully enough there that you'll be going into that exam feeling nice and confident tomorrow. So I do wish you the absolute best of luck, and I will see you ready for the next videos where we'll be looking at paper 3.